Hello everyone, we're back. So where had I got to last time working on this? We have the main ingredients of the gameplay. The Greek letters are trying to shoot me. I can shoot the Greek letters. There we go. I can refuel. Need the letter A. I'm about to die. Yeah. All right. Crasharoonie. So yeah, and I was Mike and Alan found a link to the to a emulator that runs in a web browser, so you can play Astro Warrior, which was the published version of Lettoroids, where they they made me change the letters into some abstract symbols, and I played it the other day, and it's the first time I played it in very long time. And I noticed I didn't understand the game. I'd forgotten the rules of that game. And I think the rules had changed. They're not the same as they were in the original game. Now, the original game, it no longer exists. The problem there is that I'm unsure about what the precise original version of the game was. Doing it from memory, I do not recall. So this is going to be interesting. But the way that particular game works, I don't like it at all. I'm kind of suspecting that the publisher asked me to make other changes as well. But by the looks of things, it kind of ruined the game. It's got this weird thing that happens that instead of it being the way that I remember the game, you have to kill a certain number of the Greek letters in a certain time. So it's like you have to kill all the alpha letters or whatever in one pass when you are clearing up. It's really weird. I worked it out, but it's like you have 10 lives, and then the way it works is that the rounds end when you kill all of the Greek letters. That's the weird thing, is that's not how I would have designed it originally, as I remember. I kind of remember it as being you had to clear the primary activity is refueling, not shooting the enemies. And the enemies interfere with you refueling, is how I remember it. So I suspect that game wasn't just they changed the graphics, that they asked me to change other things too. But basically, it was like I had the game and I was just to try and do something with it, so I'll just publish it. And I was already doing the BBC Micro stuff by then. So I don't think I got any money for it or anything, really, to be honest. But what I'm going to do is stick to what I think it was. The way I think that the game worked. And that would be that your activity is to clear up all the letters. And so, because you see, the game that was published is really difficult, and there's an argument that you just want to start off by refueling, and refueling is hard enough as it is. I mean, if it's just trying to get around all these and without colliding with the wrong letter, and this is quite pleasant. The stress of trying to, of course they're shooting at me. They might kill me like that. The stress of being attacked at the same time is, yeah. So I will be giving that a go. But what do we need to do today? I think I really need to have some kind of scoring system. I also need to create some kind of levels. So where shall I start? I have a think. Play that. I mean, we don't really want to have the enemies always there. And it's possible that is the way I did it originally. I don't know, but it doesn't feel right. Okay. Oh dear, it's that point. Where to start? And there was a mistake I made with the system, so that it wasn't displaying the right thing here. I have about, when this reaches 1/800, it means I'm out of memory. For a 6K machine, we're nearly there, so there's that too. The other thing as well was that the game had a different this ship here is turning is a pretty, it's not tight enough turning circle actually. I want to change that. So let's see, how do I do that? I find that code for turning ship. Update ship status, increment, ship turn, ship turn count. I'm using 8 frames per whatever. Let's try 4. That is 4 is a bit not good enough. Right, I think that is probably the one that matches the way it was in the published game. Right. Hi, B1. You're a guitar player, aren't you? I think I remember your channel. A strange idea of fun, if you say so. I mean, fun is sort of what I do for a living, in theory. And the other thing I need to do is to make it so that it will, the ship will crash. I should be playing guitar. I will be. I'm working on that. I'm working on the performance stuff, so I'll be doing some of that too in the future. I've been spending a lot of time learning to play the flute recently. But the guitar playing, I'm getting back into that. And I wrote a new song, which is always good. Why do I stream to no one? I'm not streaming to no one, I'm streaming to you. Usually by now there would be a few people here, but I guess today is, it's Easter. Where's my letter B? What happens at this age? It's not accurate. It says that there's only one person watching, but yeah, oh, KO2. That's it. Sorry, I missed it was a different person there. Exactly. How you doing? Been a long time. I could very easily end up alone at Easter, but fortunately I've got Karina, so I'm not going to be alone at Easter. Ow, what happened there? I hit the Windows key or something. All right. I think that turning circle is better. Oh, you finally made it to Germany. Okay, are you enjoying it over there? You escaped the madness of Brexit. I think I need to do the score. I feel like doing the score because I'm umming and ahhing about the other stuff. The scoring I need. Are you enjoying your new job? You remember Letteroids? All right. So I think what I had for the score on the screen was 8 characters, 8 digits. I need to put them in. Where do I put here? On the sprites here. Let's just go for it. Digits. If I follow the same, I might as well follow the same format as with the sprite data over there. 4, 5, 6, 7, 8. And so each one of these is going to be for digits. So if we do that, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12. I guess this would be then 16 here. One, two. Why not? Do it. Just do it. It's really good. It's good for you. It's good for the brain. It's good for your engineering skills. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, the simple times. Exactly. So if I'm going to put the first digit in as being a nice 0, that's going to be 7. I don't know. Depends the style of the 0, doesn't it? But let's do 7. No, it's 7E. 7E. 8-1. Oh, but if I put the diagonal bit on there, I don't know, how would that work out? It'll be 1, 2, 3, 1, 2, 3. Ah, can I, oh dear. One, 2, 3, 4, 5, 6. And then the digits here, I suppose, to do the, I mean the diagonal on the 0, which I always love. So if that's going to be my digit 0, and the hex for that is 7E, 8-3, 8-5, 8-9, 9-1, C1, no, A1, C1, 7E, programmers graphics. This food was weird. According to this, nobody's watching right now. We've ended up with 0 concurrent viewers. And the graph that they give me to show me how many people are on the channel are saying 0. It's flatlined. Amazing. I suppose when they want to discourage you, they do that. Is that why it works? 7E, 8-3, 8-5, 8-9, 9-1, A1, C1, 7E. Is that 1, 2, 3, 4, 5, 6, 7, 8? Well, it's all entirely possible that you're not real. I mean, you could just be a figment of my imagination. But I mean, you know, you could be a figment of my imagination, actually. I could be, no, or the other way around. I could be a figment of your imagination, I mean. Two, 3. It's always the dilemma. It's like you're doing the one which, oh, there needs to be a gap. So my letter sprites, they are not a gap. You couldn't put them side by side on 8 pixel boundaries. They would be touching. I need to redo my 0 because I need to make it 7 by 7. I've got, so that gets rid of the dilemma about which side you put the vertical of the eye. Very important. Does that work? Oh, now I have the problem of, do I do that diagonal sort of high or low? It's all design choices, you see. Video game development is all about important choices that one has to make at all times. That looks pretty good. All the games I did were two in the middle. I'm not a two in the middle guy, you know. It's like, it's not two in the middle. I mean, you can try two in the middle. In the middle, certainly the middle. Come on. That's just obscene. Come on, that's not. No, I'm sorry. Very. See, that's. I think that's better. It didn't work. Yeah, I'm glad you agree with me. It's like it would be a shame if we disagreed. Where were we? 7E 81 83 85 89 A1 C1 7E. I think it's almost the same. No, it's not the same at all. This is not E. Jeez. 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4. Oh, maybe I'll just do this. Oh, 1. There. Right, so the hex for that is 7C 82 86 8A 9 2 A 2 C2 and 7C. So we have to put those in. 7C 82 86 8A 92 A9 C2 and 7C. That's the digit 0. Wonderful. Now we want to do the digit 1. One, 2, 3, 4, 5, 6, 7, 8. How about that? It's a little bit ugly with that really long base, so we do that instead. I think that's good enough. And this one is going to be 1 0 3 0 5 0 1 0 1 0 1 0 1 0 7C. And we'll put those in 1 0 3 0 5 0 1 1 0 1 0 1 0 1 0. 7C. Superb. I'll get on to do 2. To do the digit 2, we start here and we come up here and here, and we do here, 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 here. It comes back to that, that. So let me just check. 1 2 3 4 5 6 7. That's a little bit ugly. It's not quite right. I don't like that. I suppose we could just... No. Another way is to bring that down a bit and then maybe put one here. That's a bit better. Ew. That's horrible. Sorry, let's just undo that a minute. That looks ugly as well. I'm squinting, so because that helps when you're doing your pixelations. We could try bringing this down one more. That's pretty ugly. That would be quite nice if I could just get that joined up, right? It just has to join up somehow. Ooh. No. How about... Eventually you get there. No, I'm going around in circles. This is annoying. So what I could try, it might be easier if I just made them 7 pixels high instead. You know, I'm going to do that. So what we need to do then is that gets rid of this question here. We just get rid of, yeah, we just get rid of that one. So get 7C, 8, right, 7C, 8, 6, 8A, 9, 2, A9, C2, 7C, and we'll just keep 0, 0 at the bottom there. 7C, 8, 6, 8A, 9, 2, A9, C2, 7C. It's just having it so an odd number, it just makes life a lot easier. Similarly on here, I'll get one of these 10s, one of these, so that becomes, it looks a lot better, I think. And we go with 10, 30, 50, 10, 10. We end up with 7C here, and the last one 0, 0, and that's digit 1. Digit 2, then this, by doing that, this becomes, I think, 1, 2, 3, 4, 5, 6. Was I already trying to put it into 7? I think I got myself in a 1, 2, 3, 4, 5, 6, 7. It was easier with the 8 for the 2. I feel such a fool. Well, it's going to make it easier when I do like the number 3, or so I'll have to make it work. It didn't help the 2 at all. Is that all right? Not quite. There's a gap. The 2 gaps. Couldn't we do this then? That was a mess up, that was. If I could do it like... Oh. Oh, wait a minute. I can move it back like, oh, I know what I can do. I think I've solved it. I've got all the way back to the beginning again. You mean, is that all right? Let's have a look at the little screen there. I suppose so. I suppose it's all right. This is very upsetting. So we can take this. There is another possibility with this, trying to solve this particular problem. Which is to do that. and then that, and then that. That's the that one I like. That's I think is good enough, right? I mean, it's not fantastic, but I think I'm going with that. So what we have then is 7 6, no 7C, 8 2 0 8 2 0 2 3C 4 0 8 0 and F E. So I think that would give me my character 2, 7C, 8 2 0 0 2 3C 4 0 8 0 FE 0 0. We get to the number 3 now. 1 2 3 4 5. Now 3. We need to start with that. 1 2 3 4 5 6 7. It's quite pleasing. There we go. That's your classic 3, and that one is going to be 7C 8 2 0 2 3C 0 2 8 2 7C. Maybe, but when you compare 3 with 2, you can see that 2 and 3 have a connection now, so kind of there's a consistency in the font. Okay, 0 0 1 2 3. We do like 7C 8 2 0 2 3C 0 2 8 2 7C. Well, we go 4. Let's do the digit 4. Right, so we need to start with probably, where did I do the 1? Was on that bit there, right? So if we copy the same 1 here, so that would come 1 2 3 4 5 1 2 3 4 5 6 7, and then we need to come back on this for that, and there and there. Oh, this old classic problem when you're doing a 4, because if you do it like that, then you end up with a very thin, sort of smallish triangle there. It doesn't look very good. So there is an argument for moving these over. You can see I've done this before. And then and we move this down, and this can go like that, and then like that. You see, that's better. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this one begins 0, 8, 1, 8, 2, 8, 4, 8, FE, 0, 8, 0, 8. And we'll get this in. Sorry, it's like, this is tedious, right? But this has to be done, otherwise I can't display any numbers. This is 4, 0, 8. And this is exactly how AAA games are made as well. No. It's a bit late for April Fool's jokes. Now we need to do 5. Now 5 is basically, I always base my 5 around a 2, right? Because 5 is like a 2 upside. So what we're going to, since I've managed to construct a 2, I'm going to use the 2 to construct the 5. So we start by taking that and then, whoops, yes, I'm basically just, I suppose I could read the digits, I could read all the hex backwards. See, because basically it's a 2 with a vertical flip. You end up with a 5. Bit of an ugly 5. Can we improve the 5? I can, and what a wonderful world it would be. It would slow the artist down a bit, right? Which would give us a fighting chance at being able to ship games that are not 300 billion gigabytes in size and take 7 hours to download. Oh, never mind. I'll end up ranting again. We don't want that, do we? Artists with all their stuff. God. All that production value that you don't see after 10 minutes. How's that? That's a really ugly 5. 1, 2, 3, 4, 5, 6, 7. I can't. That's probably the ugliest 5 ever seen. It's so ugly. What about that? That's a pretty ugly 5 as well. The worst 5 so far. We could have the worst 5 5s. Alright, this 5 is a little different from the 2. Do you see? That's pretty good, isn't it? That'll do. That'll do. Very much. Yes. Alright, so that's 7E 8 0 8 0 7C 02 8 2 and 7C. And the end result, 7E, 80, 80, 7C, 02, 82, 7C. Production value. That's what this is all about. Playing Hogwarts Legacy, I can recommend that game. I decided not to stream games. I think it goes against my principles. The problem is that streaming games is a great way for streamers, for a select few streamers who get successful, to make a living out of playing a game that then people don't play because they've seen it all. What's the point of playing? You watch people play Hogwarts Legacy and not play it yourself. Think about it. So, but I've been playing Hogwarts Legacy. I think it's great. But it's interesting because the production value is pretty good. You know, extremely good, out of the reach of an indie game developer. But I wish the behaviours were better. I have this dream of a game like that, or even like Halo style games, right? Whatever, where you know, you're, because look, you go into a camp, there are all these goblins there. I mean, the game is still good, but it's just that I'm looking for something a bit more that I would really love to actually work on. I'd love to be able to work on a game that had the production value of Hogwarts Legacy, where I could create behaviours that were realistic. So what you have is you go into a camp and there might be some poachers in there, right? And what are they doing? Well, they're just sort of standing there and saying few things over and over again. And then, you know, you can go up to one in stealth mode, you know, and you go, Petrificalis Totalis. And you turn them to stone. So it's that old thing, you know, from the Metal Gear Solid style gameplay, whatever. But the others are all around there, you know, and you can hear them talking. They say things like, could really do with a nice cup of mushroom tea. Says one of the, not trolls, no, not orcs either. Goblins. And, you know, and they talk as if they're almost talking to each other. And so you go up and you kill one of them, and one of them just falls dead right there. And the others are in there, they've got no idea that it happened. And they're not saying, oh my God, what happened to Fred? No, there's nothing. It's just like, and it's like, wouldn't it be great if it was actually somewhat more of a challenge, an interesting challenge, when you had to raid some camp, where you have to figure out how to get it done, knowing that you can't just go up behind every person and sort of kill them across the yard from the others who don't even notice that it happened. I mean, they say things like, you know, hey, is anybody there? But they don't sort of question, where did William go, you know? It's very, very, very basic AI. It couldn't be almost simpler. It's the simplest AI possible. And I've always wanted to fix that, because that's the thing. But anyway, what I'm going on about is production value. The point is that I could do that gameplay, but I can't do the production value. So if I wanted to make an indie game, even for fun. I wanted to make an indie game where I could demonstrate that kind of more intelligent AI that's actually makes for, interesting gameplay. I guess I'd have to make it in a wireframe. But the thing is, you don't see the production value. You see it at the beginning. It's all the candy right at the beginning, and you see it. But then once you've got used to it, you don't even see that anymore. You you don't see all of the years of work that went into every little texture and every little. You're not caring about that anymore, because what you care about is there's a goblin, and you're going to do what it all becomes almost like boxes. And this was true with games when they were low resolution as well. You didn't care that they were low resolution because you get wrapped up in the gameplay. And I just really wish we'd moved on a bit, but we don't. We put all of the money and effort into the production value. So can we put some really strong investment into the gameplay for a change? That's all I'm saying. And it's not criticising it. I mean, as games go, it's a very good game, and I may well finish the game. I probably will eventually finish the game. It's quite a lot of. I think I played it for about 60 hours now, and I'm about a third of the way through it. So it's there's I spend a lot of time just flying around and not really doing the missions, right, and just killing poachers. But so I'm not criticising the game overall compared to other games which come out there. It's not very often that I play a game that I'll ever finish, because I normally get pissed off with them before then. But can we have something? Can we invest in gameplay, please? Rant off. I'll check the chat. Not everyone can afford every game or have time to play games, but yeah, it's true. You can watch. That's true. But then on the other hand, I just know that thing that hit home for me with that was on Grand Theft Auto, that's whichever one it was, the live one, recent one, whatever, the one where you can. I saw a video of stealing an aircraft. And I was watching her steal the aircraft, and he's flying around in the aircraft, and I'd seen that. So why would I want to do it now? So I'll get the game and I will go there and I will do that. And I've got no inclination to do that. To think, yes, you can do it. It's really exciting when you do it for yourself. That kind of thing. You find that. You go, oh, wow. But if you just watch somebody doing it, then after that, it's like, wow, okay, you can do that. Cool. I don't need to now. I'm just making that point. And so you can say that people can't afford it and all of that jazz, but in the end, it's causes an issue that means the game developer has to figure out how to pay its employees, doesn't get paid for the work that it's done. This happened with Bossa Studios. I was watching, their game. What was it? Surgeon Simulator 2. And Surgeon Simulator 2, it was a hit with the streamers. It was a perfect game for if you're a streamer, you could get a lot of, get your followers, your community interested in watching you play the game. But if you're not careful, you end up with a game that's designed to please streamers. And then the streamers, it's good for the streamers, right? But nobody will buy the game because they don't need to. It's a double whammy with that one. It's like people go to streamers to say, we'll get our publicity from the streamers. But they forget that the publicity from the streamers is also a spoiler. And it's a very interesting dynamic. That's all I'm saying. Splash damage doesn't have that production. Yeah, splash damage does have production value. I'm not. What my comments are about the industry as a whole, and not about splash damage. It's about the industry as a whole. I say I wish we. I'm not. Should clarify. I'm not talking about splash damage. I'm talking about the industry as a whole. You know, I'm not working in games at splash damage at that point, because what I do is more about the discipline of engineering. So I'm definitely not involved in design. I'm not influencing design decisions on games, and so please understand that what I'm saying there is about the industry as a whole. Having been in the industry for 40 years plus, I tend to make commentary about the industry. But it is true, this problem has been there for a long time. When I was working at the 3DO company, I had a dream to try and fix this problem. So I've seen this problem for a long time. I never really had the opportunity to fix it. So, you know, talking as an indie game developer, I'm saying it would be great, wouldn't it, if we could have that. But it's difficult to do. There are sort of reasons why it isn't done. I could go into that. So hopefully that, but not now. Hopefully that clarifies that. I never played Hitman, so maybe I should. These days you can just buy an asset pack. Yeah, exactly. But that's always been the case. Art is easy to market, but gameplay is not easy to market. You can show the graphics, you can't show the gameplay. You can stream the gameplay, you can show someone playing the gameplay, but then you get caught out with the thing of why should you do that? Like if like for me, the most amazing parts about playing the game Elite was probably the best thing that happened. It was one story about how I escaped when I jumped into a system and I escaped by the skin of my teeth. It was really exciting, and I've always remembered that moment. But if we were to look at, say, a more sort of story-driven magical moment from Elite, was when the first incoming message with a mission appeared in that game after I'd been playing the game for a while. And it was a mission, and it was like I was already really enjoying the game, and then suddenly this mission comes in. It was just an amazing moment because I didn't know about it. I had no idea that that was going to happen, and it came in, and it was like, wow. But now, if you watched me escape from that, you know, from that system, or you watched me receive the incoming message and you'd seen it on a stream, you will never then be able to have that magic moment. Spoils the magic. Probably going to get to the point where, well, we're already there, aren't we? Do people stream watching film? It's like you could have a streamer streaming watching a film, and only they fast forward it. The boring bit, I don't know. I don't know what I'm saying anymore. Yes, they did have missions in the BBC version. Hey, ZX, how are you doing? Well, welcome. I haven't got to your chat yet, but I just saw there they didn't have missions on the BBC version. They did. They had missions on the BBC version. I know because I got the mission on the BBC. I was playing the BBC version, but I think it happened after about a day of playing the game. You had to play for a while before you got the mission. Alessandro, ciao, happy Easter, buona Pasqua. So the visuals have all been the same for about 2 decades. Yes, that's true. They don't change. It's like, can we have something new, for pity's sake? That's why one of the reasons for going back to things which are old is that they could be, come on. You just don't know how my heart breaks on this. You don't have any idea how it eats me up, and I know how great it could be. And yeah, it's the same. We have the same formula, the same patterns. I'm totally relieved when somebody manages to use the same formula and the formulas and the same patterns and creates a good game, as is the case with Hogwarts Legacy, for example. You know, I'm delighted when that happens. That's a good thing to have happen. But come on, they can do. There's so much potential. There are things. There are things I could do with a game like Hogwarts Legacy. You just. Can you imagine if you combined the kind of AI that's required to coordinate a football team and you put that into missions? You know. And I'm very interested in balance too. It's like there's always asymmetrical. The gameplay is always asymmetrical. And it's because it's a cheat. It's an easy way out of the problem of putting in gameplay, of making the gameplay sort of fun or accessible. It's like you can go up behind people and you use your stealth. Why can't they do that with you? And the whole dynamic would change if that was the case. And of course there's a problem with that. We know what the problem is. Well, you can't have that because then the player is going to be just standing there and suddenly they die and they don't know why. But okay, so be a game designer, solve that problem. Say you want to have symmetrical gameplay and then figure out how within the world of, in this case, would be magic, right? Hogwarts Legacy, this whole thing of wizards and magic and all the rest of it. If you want it to be truly believable, and that I think is important, then you need to figure out what the systems, the rules of engagement are, and why it is that, you know, you can't use petrificalis totalis or whatever on people all the time. I mean, it's just like you can go and it's really, really powerful. That part of the thing they've done is they got around this problem in the story by basically saying that you in the story are special because you have access to this ancient magic. And so you've got things that moves that you can do that other people can't do that are very devastating. They are limited, so that's fine. You know, you can't use them all the time. You have to charge them up. All right, okay, it's very standard stuff. But that's good because that explains why it is that you are different from the rest of the world. But then they also put in the petrificalis, you know, the sneak attack, and so they should be able to do it to you. And they do sometimes do it to you, but when they do it to you, for some reason, it doesn't sort of kill you immediately. So then the world starts to become less believable. And then that's a shame. So can we be more sophisticated? That's all I'm saying. And I think we can, but we don't. You're unlikely to ever see more. I'm on my way out now. I've been in this business 40 years. If the industry really wanted more of that kind of stuff, they would be doing it. And they don't. I've been bemoaning this for a very long time, and it isn't going to change. So I've resigned myself to the point of view that game designs, the games are not going to evolve anymore. Not really. Not the a bit like with film is you don't really see very much true innovation anymore in film or TV shows. You're not going to see it in games. We are seeing everything that we'll ever see pretty much, I think, now. It's impossible. You know, I'm not saying the talent isn't there, but there is no avenue for people who have weird and wonderful ideas to sort of do that. I mean, we need, well, it's true in film there are. I like, what's his name? The guy who did, what was it, Eraserhead? I've forgotten his name. Terrible with names. But it's like we could do more characters like that, you know. For pity's sake, somebody with money needs to find a designer who has some off-the-wall ideas to turn that into some new games. I mean, because that does happen from time to time with film. Can we have it happen with games, please? Thank you. They don't have missions. All right. The tape versions did not have missions. Oh, right. Well, it's possible that I was playing Elite with the disc version. So it's weird because I didn't have the discs at that time. I'm a bit confused about that, but I'll take your word for it. Is this not solved with online PvP? I can just use the game balance, but no, it's not. It's not solved with that. That got killed too. That was the idea, was that we could use online stuff. Sure. We could do online gaming. Online gaming was going to be great. We could have people teaming up and sort of doing tactics with each other and so on. Why the heck not? Let's take a great game that dropped the ball. And you have to wonder, why did it drop the ball? But you can take Star Trek Bridge Crew. So there's a VR game that I actually really rated highly. I enjoyed it thoroughly, but it would not have taken much to make it even better. But what happened is that all the parties that were interested in the game, and you should see the credits on it. The credits are just like, what the hell are all those credits for? The game isn't that complicated. So it's almost like, hey, we're doing a VR game, and it's going to be, well, it's a VR game, so that's the new thing at the time. So yeah, let's get our name on a VR game, so you have everybody you can think of on there. And it was coming out on PlayStation, and well, it was a multi-platform game. But Ubisoft dropped the ball with that. They just went and continue with it when it had great potential. They don't do that. So they look at their bottom line, or they want to move on to the next thing. They don't, right? What would have been fantastic with that game is if it could have been multiplayer. And if they had done that, the game might well have exploded, because then you could have a battle with two crews. Because if you haven't played Bridge Crew, the idea with it is that you have a captain, you have the helm, weapons officer, and an engineer, and you have to keep the ship going during a mission. It was about teamwork. And the captain actually behaved like a captain. He was actually giving the instructions to the crew. And you learnt a lot about being a member of a crew, or trying to be a captain of a crew. And it was actually very interesting in the psychology as well. And you would have random people, there'd be random people who'd be on your team normally. And then you would get people who were insubordinate, and you have to figure out how it is. I mean, I remember being a captain and watching as the whole ship was getting blown up because nobody was responding to my instructions. They just do their own thing and ignore the instructions, and then boom, everything was, distressing, but it's very interesting. And but can you imagine what that would have been like if it was PvP? Gosh, it would be intense. It would be a thing of wonder. And they were so close to having that. They had put in all of the production value. They had all of the VR systems in there for doing all of that. All they needed to do was just connect the two things together. It wouldn't have taken, connect two different people playing the game together over the network. It wasn't as if the technology for doing that would have been difficult. The gameplay is slow, it's not fast. Gameplay would have gone over you could have networked that really easily. They didn't do that. Why the hell not? Because why not? Because the shiny toy. That's my only reckoning of it. I mean, why would you they've got to move on to the next thing. And, So the point there being, network play, first of all, is for some reason those opportunities are not taken. I've seen. I'm not really pointing the finger at anyone. I'm just giving an example. But the other problem is that where you have multiplayer, that's been spoiled by toxicity. So lots of gamers are just not interested anymore. They're given that dream died. The dream of the wonderful experience that you could have with multiplayer gaming kind of died. You can still have it. I'm not saying it's not completely dead, but the dream is somewhat dead. For me, the idea of going and playing an online multiplayer game, my first consideration about doing that is am I going to get griefed? And I know that a lot of people feel the same. So that needs to be fixed. And that is not an easy problem to fix. That's actually a hard problem. So if I was thinking about making a multiplayer game, why not? What's a good reason to not take Bridge Crew and try to make it multiplayer? An excellent reason not to do it, and probably the reason that he actually didn't do it, is because it would just open the door to even more toxicity. That's probably why they didn't want to continue the game, because you would use voice command. You're talking to each other on the flight deck in that game. Although it was PvE in there, yeah, you can see how you're opening yourself up to a whole bunch of trouble. I don't know. In which programming languages modern soccer games like FIFA are developed? C. So they're probably developed in C, C++. I think the FIFA source code probably goes back to 1994. So it's possible it was originally in C and they still use bits of it, but I have no idea. FIFA uses C++ with EA's Ignite engine. But since when? Do you know which year is that from the beginning, from 1994? Because I do know that 10 years after FIFA was released in 94, they still had the same bugs. Little glitches were still present in the. I could tell it was basically the same code. Yeah, you hate playing multiplayer, just play online. Offline, yeah. Minecraft because you need to play over a LAN with your kids. Isn't that sad, though, that we don't have a way for people to play? I mean, we do have ways for people to play multiplayer online. But, people want a nice experience, entertaining, fun experience. And it's almost like if I was to make an independent game that was online, I would make it adults only. Not because it would have adult content in it, but because I would want the adults to be able to play a game made by an adult for adults without having screaming kids in there. It's an issue. It's an issue for sure. It's very you play. I mean, it's like on the VR. There was one game I was playing. I think they're closing it down. Of kind of, is it Echo VR or something? It's like a sports type thing. You throw like a frisbee or whatever. And so you join that, and you try to go, and it's team sport thing. You try to do that, but then you hear these obviously kids, and then sometimes they're doing quite rude things with their animations, and you just you going. I feel like I'm taking a tour through Chuck E. Cheese. I don't know if you know Chuck E. Cheese in the US. I used to live in the US for about 5 years. I lived in the US when I had my daughter. And we would young daughter. We go to Chuck E. Cheese. It has exactly the same kind of ambience there. You go there with your daughter to Chuck E. Cheese, and you're in a world of young children running around, screaming, and all of that. And you obviously put up with it because you want your child to have a nice time. That's fine. You're playing your video games that you. I don't like Chuck E. Cheese. Thank you. Yes. Anyway. Would you consider kickoff for the next? For the next what? I don't understand. Then would you consider KO for the next kickoff? I don't know. I could never do kickoff again. I don't think. I've had enough. It's like I don't know. It's all very strange. Make a game everybody loved. Well, not everybody loved it, but half the people why half the people loved kickoff and the other half hated it? Is because it was such a skill-based game. You either had it or you didn't. And if you had it, you'd beat those who didn't have it. And ultimately, people would play each other, and it was very difficult to ever improve so that you would beat somebody who started out beating you. If you both practice at it, eventually, you're both improving. So what tended to happen is that people who lost continued to lose, and the people who won continue to win. And so that was a 50-50. This is where it comes from. So half the people who play kickoff love kickoff because they always won, and half the people who played kickoff hated kickoff because they always lost. So there you go. It's just we can't have fun. Apparently, there's no way around it. It's not quite right. I mean, they've sort of figured it out on chess.com. So if I was to try and do something like that, I would look at the way that things are working with chess, because people play chess. Mysteriously, they play chess. I think it helps to have a lot of people who do it, so you can find people to play against that are at your level, right? And then from there, the thing it can work, but it's very interesting. We got to the point with chess where people aren't upset because they lose or that their rating isn't very high. You accept that, and you just sort of, well, that's where I play, and that's fine. But a lot of people who play video games will just look, especially when they play and they can with online tables and so on, and they play the game, and they, oh, that was hard work, and then they look at their ranking. So you're ranked 275,000th. It's like, I haven't reached the point where it's to do with intrinsic motivation. It's the extrinsic motivation that counts, and the younger that the audience is, the more it's like that. I'm rambling about all kinds of things now, aren't I? 2013. Okay, so that would probably before 2013. FIFA were using the same code base that went back to about 1993 is my guess. It's totally a guess. I don't know. My kids play Gorilla Tag VR, and the kids on there yell the N-word constantly, and they bully people who don't do what they want. Yeah. Brilliant. That's what it's come down to. Hewlett Packard, one of the world's leading technology companies, now sells ink, video games, the, the medium that could change the entire world and could provide for so many things, specializes in toxicity. It's all one thing reflects upon the other. Kickoff has had its day in the sun, and so has many other things as well had their day in the sun. My dream game as a designer was always make a new player manager, but I couldn't imagine it being made without Dino, so I never tried to make a football management game. Yeah. We did try, but yeah, I don't know. It's yeah. I'll get back to my digits, shall I? It's so this is it, you know, sort of you're a passionate thing, being passionate about something like making video games, and then you spend the rest of your life trying to chase that. Sad. 1, 2, 3, 4, 5. So one I can do though is I can go back to where I started, and I'm remaking my first assembler game. 1, 2, 3, 4, 5, 6, 7, and that makes me feel good. Because it reminds me of who I am as a game developer, which is, you know, to understand that you have to go back to where it started, and like, you know, you kind of lose your way, all the trials and tribulations, the getting ripped off, the people who attack you, but when I was making these games originally, it was a hobby, it was a passion, it was pure, it was and I make a living out of the video game industry because I can program, and I'm a good programmer, and so I don't think about the games. And from a game design point of view, it's like it doesn't matter. Now I can't get there. I'm trying to get a nice 6 here. There's something bothering me about this 6. Should I do that little dot there or not? It just looks a bit kind of unbalanced somehow. Oh, it could be that. No, that's horrible. That doesn't work. Maybe that top piece should be not so. A moment. I want to sort out this digit 6. I'll look at the chat in just a moment. Oh, that could be it. Maybe with an extra one here. Oh, that'll have to do. I'll be here all day otherwise. Okay, so that one is 3C 40 80 FC 8, 2, 8, 2. I said FC, yeah, and then 7C. Right. Licenses and loot boxes, because that's it. Can we check? Can we talk about something nice? Because I think I'm getting very sad now. As I think about these things, it's like it's my demon that follows me around all the time. It's like Right, we're gonna try 7. All I ever really wanted was to be taken seriously. One, 2, 3, 4, 5, 6. Do you know? I think I should put that on my tombstone. It's like all I ever wanted was to be taken seriously. It would 1, 2, 3, 4, 5, 6, 7. That would summarize me very well. I think I quite like that 7. So this is going to be F, 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 E, 0, 4, 0, 8, 1, 0, 2, 0, 2, 0, 2, 0. 1, 2, 3, 4, 5, 6, 7. And we can get that in. FE 0, 4, 0, 8, 1, 0, 2, 0, 2, 0, 2, 0. We have our 7. I'm nearly done with the digits, so if you're... Then I need to write the code to display the scores. A game you worked on was just released for Easter. Excellent. Hi, Apple Time. I do play jazz music, yes. I do have some examples of that on my YouTube. ZX, okay, you have to work tomorrow. Yeah, commiserations on that. I've taken the whole week off. Yay. How many people are on it? Yeah, it says there's only one person watching. I hope they're not shortchanging me on my viewing hours. Jeez, what is wrong with this thing? If I could be an influencer, that's what I need to do. I've got this stupid plan. It's to go against all the odds. It's to become an influencer. Then if I could combine my knowledge and experience of game development with being an influencer, there'd be nothing to stop me. I could change the world, or I could at least... I'm making a game. I could do that. Who knows? Who knows? Things might not always be dark. Maybe there is a light at the end of the tunnel somewhere. There's 6 likes on the video. If there were 6 likes, it says 5 for me. Maybe someone removed a like because they said, oh, what, listen to him. Oh, God. Yeah, I liked him until he said that. No, but yeah, it says 1. But there we go. The statistics are terrible. It's like average view duration, 4 minutes. It's like on average, people watch for 4 minutes. Really? Hey, Apple. Yeah, it's fine. Actually, my channel is doing better than, it's doing well in the sense that I'm actually seeing progress. It's like I can see that I can build this. So there is always that dream. It's always there. It never really goes away. And one day, I might be able to make the game that I've always wanted to make. But I can't ask anybody for help. I have to do it all by myself because I'm a big boy now. But I could ask help from people. Like from viewers, maybe. Or not ask help and just get advertising revenue. One, two, three, 4, 5, 6, 7, 8. God, what's wrong with Dino? He's getting a bit of funny mood. One day when I grow up, I want to be a YouTube influencer. When I grow up. It's actually quite refreshing when you get to the age where, you know, just getting through the day is satisfying itself. I got through the day. I lived another day. Good morning. Will I get through this day? I mean, in the end, what is there? That's all there is. It's like I envy the flowers. They just do their thing and they don't have any angst. So it's really good to get rid of the angst. It doesn't help anything really. They're not worried that they're in a little, well, they never are actually. Flowers are never in a maze of twisty passages or the like. Us human beings, though, different story. I don't know why I said that. It's because I'm doing this thing. I'm just doing the hexadecimal. This is what happens when you're doing programmer graphics. Making your own font out with hex numbers. At a certain point, you just get belligerent and just say silly things to yourself. If you're not streaming, and if you are streaming, then you can be sort of legitimately talking to yourself, but you're not really talking to yourself because you're talking to people. You can kid yourself that you are, and then you can say, I'm not going nuts. Right, 1, 2, 3, 4, 5, 6, 7. Right, I've got to 9. Which is just a demonstration of the fact that, you know, persistence pays off. That's one thing. And the other thing is that ranting doesn't help productivity. So let me put these in and then I can start working on the code for this is needed for the score. You know, in a pure world of game development, you wouldn't even need a score. Just the fun of the core mechanic would be enough. A lot of games these days don't have scores and don't have fun mechanics, so tell me. I know. Oh boy, I'll get in trouble one day. I'm going to just check the chat now. Right. They see Emacs and run screaming. Go. Good. When you do programming, everyone wants music, and when you play music, everyone wants programming. I will be doing more music. I have been on that side on that side of things, I've been sorting out my performance stage, which is basically here. But I need to, I've got these, I'm using it for the lapel mic as like a little, you want to see something? This thing, which I got off Amazon. So that's a radio thing. So I've been experimenting with this with my guitar as well to see what the setup is for audio quality, and I think it's going to probably work out quite nice. But if I'm doing music, I mean, it's more of a difficult setup. I figured out how to use Cubase to do the the audio processing in real time. And that's quite nice, because then I can really try to get the production value of the audio, because production value is very important, of the audio to a high standard for live performances. So I was experimenting on that last week. Basically, if I'm not streaming, if I'm not streaming this, I'm working on getting to the point where I can stream music, or I'm working on more sort of administrative stuff, that is like tidying up, getting hold or organizing archived data, planning stuff, making videos, because I have to release the next part of the normalized tunable sigmoid function video, which has reached 50 views. These heady heights. Yes. 50 views. That's an achievement for me. Then there's the other video, which is part 3 of Take the Label Off the Table, which is a philosophy video. I think that's not long now before it either gets 15 likes or 120 views. So I'll be needing to organise that as well. So there's plenty going on. Yeah, I'm going to actually, you've got a point there, KO2. I'm going to get in touch with, no, rewind. I'm going to try to get in touch with YouTube and ask them about it, because it's a bit off. I mean, apart from anything, it means that people who come here and they join the channel and say, what, he's only got one viewer? He can't be any good then. I'm not going to watch someone who only has one viewer. It's very strange. But what's likely to happen is that they'll simply say nothing, because I'm a nobody. We're all nobodies. We're all nobodies together. Where was I at? I've actually finished. I didn't realise I'd finished. So I've actually finished the numbers. We do have the numbers. I did realise, but I've forgotten I'd realised. So now I need to draw these things. The routines to draw them. Shall we do that? All right. So what I need to do is... Oh, and when do I update these? Oh, we could get very fancy. Now, actually, a straightforward blit from memory, from RAM to VRAM is fine. I don't need to rotate these. So I'm running out of memory. I'm probably not going to try unrolling them, but there's less reason to unroll it because it's a simpler blit, I think. Yes, it's a simpler blit. So what we'll do is call this draw digit. Let's put this into ASM mode. What happened there? Weird. ASM mode. What shall we do? The first, we need to figure out what we pass into this, I suppose. So following a similar pattern to elsewhere, x is going to equal the digit. $80 is going to be the address. This is the address. Why don't we just use a consistent notation here? The digit, the address. So I say, okay, I want to ask the digit to the address. And so oh, well, okay, my problem is memory is getting short, so I need to make it more compact in terms of code, in which case I should use the indirect indexed addressing mode, which I could use x and y for this. Y and x is the digit. Oh, as I move so so I'm just working out in my head the different. The problem is that indirect indexed, which is the most useful of the addressing modes, which allows you to have an address in zero page memory, say in 81 and 82 or 8081, and it will add the Y register to that, and then you can load or store to that particular thing. It's a very powerful instruction, but it's only with the Y register. The X register does a different thing, where you can give it say 8081, and it adds X to 8081, so that it could be, say, add 16, you end up with 9091 as where the address is. And this is indexed indirect. And you have to use the X register for that one. You can't do indirect indexed on the X. Now, I need the indirect index to access the memory. I need to use indirect index to access the memory as I draw the sprite, because I can increase the Y register by, say, in this case, 32 bytes at a time to go down each of the lines. So that's straightforward. But where I pull this from, I have it set up in a little, what's now a bit of an awkward way, I suppose. I have to add 10. Oh, ouch. It's not a problem. Basically, the bottom line is it's easier for me to do it unrolled. But then I'll just do it unrolled. Oh, but that's scaring me, because that means that when it comes to me wanting to unroll or roll up some of the unrolled stuff so that I get some memory back, I'm going to have trouble. It's going to absolutely sink the performance of my sprite drawing routines. All right, I'll worry about that later. The issue then here is that when I need to pull these out of intervals of 10. They said 10 bytes apart. So I take the top row comes from here. The next row I need to go 10 down, and then I need to add 10 each time. How do I add 10? To the address that I'm reading this from. I can use indexed indirect as long as I keep the X register at 0. There is also a trick that can be done of using indirect indexed one with the X. I can also do a thing where, in order to do a fast operation, I set a sequence of pairs of addresses in 0-page memory and switch between them using the X register. That's also true. I can use that probably to get around some of the... Right, anyway, back to this. If I have a gap of 10, I would need to add 10 each time, unless I unroll the loop, in which case it's hardwired, which is definitely the fastest way of doing it. And I am only doing 8 bytes. I don't need to do 16, which is the case when doing a sprite, because it has to scroll. And so then it comes, in effect, 2 bytes wide. I have to do 16 bytes there. That's unrolled at the moment, so that sprite routine is unrolled twice because there's 2 buffers as well. It all mounts up. I think I'm just going to stick with the simplest approach because I have memory right now. I can optimize the memory later. That decision made. So what I'm going to do is load the accumulator with digits plus 0. I put the plus 0 in there because it makes it clear that there is an offset, in this case of 0, because the next one is going to be not 0 anymore, the next thing. And that's that. And then what I want to do is exclusive OR it with... I need to load Y immediate 0 when I have 0 in my Y register. Okay, so I've loaded the digit in. I need to do an exclusive OR with the $8 0. Hey Refly, how you doing? Refly has joined the channel, which means I presume that there are now 3 people watching, but it says only 2. Still, it's like it's terrible. Look at this. Look at this. Look, I'll show you. You can see it all its annoyance. Look, I'm so annoyed. Because you know what? I mean, it's like this good to be annoyed. The reason why it's good to be annoyed is because when you're annoyed, and even for a long period of time, it's like being hungry for a while. And then eventually, if you allow yourself to be hungry when you eat, it's so delicious. So I'm going to let myself be annoyed so that then when something nice happens, it's going to be so delicious. There we are. There's an explanation for everything. Where is the flipping thing? Oh, desktop. There. There's, look. Oh, go over there, will you? Look at that. I mean... it's like one viewer. I mean, never mind the fact that up here it says there are 2 concurrent viewers. I mean, here it says there's 2 concurrent viewers. There's only 2 of you, apparently. Can you do me a favour? If you are watching, can you just sort of say hi? I mean, because, I mean, it's like, I want to know. I want to know. Is that... But there, look, you've got that too. But down here it says 1, and the graph says 1. It's like... So I'm just going to try refreshing this. See? We do refresh. Oh, good thing it hides the string key. Yeah, okay. So we got there. There are 2 of you. There are two, at least. I mean, it's like, what is it with this? Was that actual? Is there one actual viewers? Oh, look at this. Views. I've never used that before. Chat rate. Current viewers. So, hey Andrew, thank you and welcome. So, yeah. All right. So we know. We know now, don't we? We know. We know that it's all just nonsense. I want to get back to Atom. There we are. Anyway, back to this. If I do the exclusive for with this, then what I'm doing is taking the first line of the digit, and I am done an XOR with the address that I want to put it to, just memory, in video memory, and that's it. And then once that's done, I can just do an add, a clear carry, and then add with carry immediate, and we'll do 32. No, yeah, I'm going to do this to the Y. Transfer Y to A, clear carry, add with carry, transfer A to Y. So the end result there is that now we've moved down 1 byte. Oh, oh, Dino, why didn't you think of this before? We do self-modifying code. Why not? We can do we can do self-modify. Of course, with self-modifying code, you can solve everything. It's just you can't put it in a ROM. But you can solve everything otherwise. And anyway, who puts code into ROM these days? Self-modify. You want to watch somebody? You want to see some self-modifying code? Oh, the software engineering police. Don't tell them. Don't tell them. Don't tell anyone. And absolutely don't tell anybody on Slack. Stack Overflow. Oh, they get roasted alive, I would. Or people are saying, if I ever saw anybody do that, I'd fire them on the spot. Well, this is it. This is why this is fun. We're going to have fun with self-modifying code. I'm not going to do this unrolled. Let's see. I think it's time for some nasty programming. What I'm going to do is, yes, I can add to it now. It turns out, because you might wonder, add 32, can you really do that? Well, yes, I can, because I need to only do 8 lines, so it fits very nicely. The Y register, 32 to jump down a line, and we're only going 8 lines, so we do 32 times 8 is 256. Everything is hunky-dory, fits exactly right. So that's good. And I can continue that loop until the branch if not equal, because the only time it'll ever be equal is when it finishes the particular loop. We do draw digit dd1. Put a label in here. I'm good here. Dot dd1, and so that's quite appropriate. I'm going to do some nasty code, and I've got labels dd. That's very good. Yes. So that will basically loop 8 times. Now the problem I have is that I need to somehow get this to jump. Oh, I don't need to do self-modifying code. I can just add 10 to x each time. Oh, that's boring. Well, let's see. If I was to add 10 to x each time, I have... Oh, I so much wanted to do it with self-modifying code. So do it with self-modifying code, then I don't need x. No, I need it for the digit. I do need x, but I don't need to change x. You put this in there with the digits. Okay. The the opcode comes first and then the address comes second, which would be DD plus 1, I guess. So what I should do is load a, I'm gonna try with the self-modifying code for a laugh. So what we're going to do is load a oh, well, it's not that simple. Load a digits immediate. I don't know if the assembler might hate me. I mean, that's always a risk, as well as people on Stack Overflow hating me. The assembler might hate me. The assembler hating me would be more of an inconvenience. $FF immediate digits add FF store a digits plus 1, no, DD1 plus 1. So I'm storing it at the label plus, it's modifying this instruction here, right? But I have to do it as a it may actually not be worth doing this, but I want to do it anyway because I just got the urge to do some self-modifying code. It's insane. This one I would have to divide by 256. So this gives me the high byte of the address, which I store in .dd1 plus 2. So I'm modifying that. Because I'm modifying that, I have to reset it first. So I've reset it. Then down here I can do that, and then I have to add 32 to there. Then I have to do load a dot dd1 plus 1, and I have to add 10 each time. Clear carry, add with carry, immediate 10, store a. Okay, self-modifying code can really be amazing, but not in this case. It's probably slower here than it would be by other methods, but never mind, that's not the point of this exercise. The point of this exercise is to annoy people on Stack Overflow. That's the point of this exercise. Load a, don't clear the carry flag because I'm doing a 2-byte increment. I need to use the carry flag. I have to add with carry 0 because I'm adding the carry flag, and then I store that back into there. I'm just checking that. Sorry, load do that, and then I'm going to clear the carry flag. And so every time it's going to add 10 to the address in the code here, and it loops around until it's finished. I want to see if it even, my word, assembled without any problem. The assembler just took that and said, yeah, okay, you can have that if you want. What's it to me? Hey, Alan. Hi, how you doing? Good to see you. We haven't had Mike on yet. Mike is hopefully going to be collaborating on the thing. We have a GitHub for this, so I'm very happy to have people contributing if they want to sort of join in on this thing. Maybe you'd be interested in that, Alan, I don't know. But if you are, let me know. Anyone who's interested in joining in to this thing, let me know. But good to see you. Oh, something's happened. Apparently the graph here has sort of jumped. There's 15 concurrent viewers. So I don't believe that because the beta has been wrong all the time. So probably there aren't. But if there are, hi, welcome. That's exciting. Should we see if it worked? Because I mean, yes, shall we? Yeah, it assembled. It assembled first time. We'll see if it actually runs first time. Yes, this is the thing. So in order to test that, I need to load the X register with, say, 0, which would give me the digit 0. And I want to draw it somewhere in the screen. So I could do that at the address 8800. Store a $80. So I have to put that address in 80 and 81, which is then on here is like 88 and 81, and then I just need to draw digit, and you know, we'll see if it works. Yeah, if this works first time, that's going to be amazing, isn't it? Is it going to work first time? I don't know. No, it's not going to work first time. So there. Okay. But I tried. Yeah, I am using the atomulator as well. This window here, this is the atomulator. And Mike was able to get his development environment working. He was using a Mac. So it should all be very straightforward. You need the ACME assembler, Acme assembler. It sounds a bit cartoony, Acme assembler, you know. What do you think of that, Lenny, eh? The Acme assembler, would that be, you know, your thing? Yeah, your thing. It is his thing. I know he's not really a cartoon, but he's almost a cartoon, isn't he? That didn't work. Okay, so now we need to find out why. First thing we could do to find out why is that we exit after one loop. We only do one loop, one pass. And then the other thing that we can do is, instead of this, I found it already, never mind. I missed one thing, one damn little thing. And can you see it? I load the digit into the accumulator, the bit pattern in the accumulator. I did the exclusive OR, but I didn't store it. I need to store it back into the memory. That's why. Gosh, Dino, if you'd done that, you'd have had it work first time. Not quite. It's a bit garbled, isn't it? Almost worked first time. I'll just check the chat. How difficult would it be to port to C64? If anybody, well, that's an interesting question. I'd be very much into that because I've never programmed on the C64. So, does anybody know of C64? We can talk about how we could port this game to the C64. We could try. It'd be a very interesting exercise. Meanwhile, this garbled thing here, well, now we need to debug that. And what I'm going to do is just add a load a immediate. I've got something to show you. This is the life on YouTube, right? But for a moment there, I reached the heady heights of like 15 people, and then it stayed, and it goes, and it's like, and now we're back to 1 again, except we know that it's more than 1. Sometimes the AI, I feel like it just does it to just, you know, string you along a bit. Anyway, what I'm going to do is load here $AA. Says 10 watching for you. Well, that's good. It's just random. It must be tied into ChatGPT. It's like, because ChatGPT doesn't really often say the right thing. That's weird. It's a little weird because those pixels are not entirely the same width, but I guess that depends on what width you make this window. That's not really a concern to me because that's not me. AA, I've got these. The only weird thing with this is that it's it's too small. It stops. after 4 lines. That's very strange. It stops after 4 lines. So we'll fix that first of all. Now, I don't need... yeah, all of that self-modifying code experimentation was to do with where we load the digits from. So I'm just going to take the sprite data for the digits. I'm just removing that and hardwiring AA in there, and what should happen is it should add 32 onto Y each time. Oh, there's the problem. Okay, so there is a problem here in that the increment of the add 32 to the Y register needs to happen right next to the branch if not equal, otherwise the flag, there we go, is messed with. So that's good. We've got all the lines there. Now let's try, what would be good? Yeah, that would be good. What I will do is try to keep this reset the modify that instruction to the first, you know, where it should be, but get rid of the increment. So what this means, it will replicate the top line of the digit over all. No, that didn't work. Why? I've still got the load a thingy here. Let's take that out. Yeah, that looks correct, because what should be happening then is it's basically 7C all the way down. So that looks good. If I was to change from digit 0 to digit 1, let's try that. And to do that, I'll just hardwire here a load x immediate 1, and we should see it replicate the pixel for a 1. So this is telling me that this modification here, modifying code here, is working. So if there's a problem now, it's going to be with the addition. So for the addition, I start by adding 10 to the low byte, and then 0 to the high byte, but with a carry, obviously. That should work. And it does. There's some. That is a 0, but with a glitch. But the glitch might actually be a problem with the sprite data. So I almost got it right first time. It wasn't that far off, right? I know you can't call it a hole in one if it took you 2 shots. I know, or 3, 4, 7, whatever. Right, 7C 86 8A 92, and it's A9. Yeah, A9 is wrong. It should actually be A2. Let's try that again. Yeah, so that we have a nice, we have a 0. We have a nice 0. Okay, so my sprite routine for drawing digits, my draw digits routine is working. So what we will do is just test this out on the top row, and I have to do that, and that's working with self-modifying code. See, it's not so scary. I'll optimize it later. That optimization will involve removing the self-modifying code, but what I want to do is put it at the top of the screen. So we'll put that at 880 and maybe move it across halfway across the screen for now, which would be sort of 10. So it should appear on the top there. Okay. That's fine. So now I can implement a score. Hey Refly, thanks for tuning in. Have a good night. Cheers. So the question now is, do we this is something Mike was saying, is that we could use the binary coded decimal mode, which is weird. The processor has binary coded decimal mode, so it can actually do mathematics in decimal. Now, why would we want to do that? The routine to convert a binary number to a decimal number is going to be quite cumbersome on a system that doesn't have a divide. Actually, the easiest way to do it on the 6502 is to use binary coded decimals. So here we are, we're going down in that road, and I can't remember how that works, so I've got to check it. I've got to read up on it. So let's see. Let's try ChatGPT. I find ChatGPT is very useful for looking up things that are. The problem is figuring out how to describe what it is that you're looking for, right? If you follow my drift. Let me try adding a window. Can I add a window, please? So I have a window capture. Why do you hope that ChatGPT kills Google? Would that be a good thing? If ChatGPT kills Google? I don't know. If killing Google would mean that, knowing my luck, knowing my luck. Oh, I see what you mean. Well, they will work on it, I'm sure, but knowing my luck, I will just be about to make it, and then Google go bust. It's like, you thought you were going to be a streamer. You were a streamer dreamer. You had a plan, didn't you, Dino? You were going to become a mega streamer so that you could finally make that game you wanted to make. And then look. Google went bust. Ha ha. Look, where was I? All this nonsense. ChatGPT. Free ChatGPT. Right. So the question is, how do I use? But you're right. When you look, Google has a real problem. Google has a real problem indeed. It's like when you look things up on Google, you don't find anything useful anymore, because everything has got narrowed down to the rat runs, and it's like you're looking for something and it goes, here's the entry from Wikipedia. Well, thank you so much for the entry from Wikipedia. Great. Cheers. It didn't occur to me to look for it on Wikipedia. How do I use 6502 BCD mode? Now this is quite obscure. It's very nice, especially for obscure things. Set the BCD flag in the process status register to 1. This can be done using the set carry. That's wrong. That's the problem, though. Just like, you can't. The set carry or clear carry instructions sets or clears the carry flag. It's got nothing to do with the BCD flag. The BCD flag is bit 8 of the P register. Load the BCD value into the accumulator using LDA. The value should be a BCD format, as in, yeah. Top, both nibbles of the byte need to be 0 to 9. Perform arithmetic operations using the instructions that support BCD mode, such as add with carry, subtract with carry. These instructions take into account the carry bit and the BCD flag when performing the operation. Store the result back into memory using the store A instruction. It is important to note that not all instructions support BCD mode, so make sure you use ones that do. Additionally, be aware that BCD mode can affect the timing and size of your code, so make sure you optimize accordingly. Okay. Look, can you give some sample code? Okay, I'm confused. It's like, isn't SEC the set carry instruction? You're absolutely right. Right, the sed instruction. All right, let's see if the sed instruction is a thing. Yes, it is a thing. Thanks, Alan. But this is funny. So I did that, and now you can see that it's running my entire game by applying binary coded decimal arithmetic instead of normal. You can see the danger. The weird thing is it's still running in some way. It's still doing something. But yeah, that's fine. Right, so we will just get rid of that sed instruction. Maybe switch it off sometime, yeah. So if I want to create a score, I need to figure out how I do the score. Of course, the problem is the score is now in BCD. That's nasty. I want to mess around with BCD. Yeah. And then there's the other side of it, which is that when I draw the digits, I have to draw the top nibble and the bottom nibble. Surely there's got to... You know what? I never really liked binary coded decimal mode. Let's ask ChatGPT. Your computer's running low on storage space. Oh dear. What's the damage, John? Oh, I only have a gig left. That's not good. Why? Why do I only have a gig left? Just bear with me a moment while I try to figure out why I've only got a gig left. It's like, oh. You know, when this happens, there's a thing that one must do. What one must do, or just what I do. You mustn't, it's not that you have to do it, that's what I do. Let's go to see, into here, we'll do a DU and pipe that into /temp/ C, I don't know, CDU, there we go, or just out, or just into out, right. And so it's going to go and do all of that. Uh-oh. And hopefully I won't run out entirely before it gets to the thing. So we go, boom, right. Let's see, just ups the ante a little bit. I'm going to ask ChatGPT about how to convert hex to decimal. How, or binary, how can I convert binary to decimal in 6502? Let's see what it says. So initialize loop counter, binary number to be converted, shift the binary number. What is it doing? Initialize the loop counter, binary number to be converted, initialize the decimal result to 0. Oh, that's the full code. Shift the binary number right by 1 bit. If the carry flag is set, okay, so for each bit, decrement, jump to add, clear the carry flag, add 0. You know what that's done? What it's done is the world's slowest. It's the world's slowest copy of a byte. It's literally taking a byte and then it's going through all of the bits, and then if the bit is set, it adds 1 and then it shifts it. So you end up back where you started. It hasn't. Dear me, it's all right. What I meant I need to get print. All right, let's see. I meant convert a binary number to a list of decimal digits. Let's see if it can do that. To convert a binary number to a list of decimal digits, you can use a modified version of the algorithm I described earlier. Instead of updating a single decimal result, you can store each digit in its own location. Really? Initialize a loop counter, the bits on there, load that number, initialize decimal digit counter to 0. Okay, loop, it's all the same on here. And you do clear add 48 to convert it. No, increment the decimal digit counter. No, what you're doing there is that's just nonsense. I can't even begin. ChatGPT isn't capable of doing that. The problem is that the way that you would do this normally requires a divide by 10 instruction. There is no way of dividing by 10. It's an interesting problem. If I can have a way of doing that conversion efficiently, it's better that I do that because it simplifies the other code. Otherwise, I end up with this weird the processing that I have to do on the score, for example, with when I have a high score, extra lives, when I reach a certain score, that is going to need to be done in binary coded decimal as well. So I'm genuinely interested in the algorithm, how you do. That was ChatGPT 3. I'm genuinely interested in how you do an algorithm to convert binary to decimal digits on a 6502 where you don't have any divide. I can divide by 2, it's a shift, but I really need to divide by 10. Well, divide by 10 is the same as divide by 8. Then what? It's almost the same as divide by 8. You can do a divide by hang on a minute. I'm just going to ask it, is there a way to convert a binary number to BCD encoding on a 6502? Okay, so it's saying you could use a lookup table. All right. Here's an example code snippet that converts a binary number in the accumulator to BCD and stores the result in memory location. Okay. That's kind of interesting. Will it work? Binary, load the binary number into the accumulator, load X with 1, store Z. Store Z. What the frack is store Z? STZ. Is STZ a valid? Can't it check its own work? Is STZ a valid 6502 opcode? There is an STZ. Okay, well, I'm like, are you sure there's an STZ? Really? I can't believe it. There isn't, is there? 6502 opcodes. Come on. I don't remember an ST. Maybe there is. I mean, it's good to know. I'll check then, you know. STZ. Is he made it up? See, ChatGPT, you made it up. There is no STZ. What the hell? Oh, no, there isn't. But it's available on some of the newer variants, such as the... Is it? Is it? I don't know what to believe anymore. Let's just... Is STZ a valid 6502 opcode? Yeah, it's in the 5CO2. We are not using a 5CO2, I'm afraid. So there we go. Okay. So, okay, well, I can just do that by a different method. Then it does logical shift right. Logical, so it's divided by, no. Yes, divided by 16. It's extracting the next nibble. Where did you extract it to? You've lost the lower nibble. You know, one should never lose a nibble. No. No. It's like, it's like for grasping at straws. No, no, and, and no, and no again, and just no. Okay. Push A onto the stack. Mask lower nibble. Compare with 10. Yeah, GPT-4 is also talking nonsense. So just bear that in mind, everyone. It's like all the things they say about these things take away the program and so on. It's like I could have asked a toddler how to do it and got as a good an answer. So let's think about how to do this, because it's an interesting question. It's like yeah, Alan, it was in the end, by prompting, ChatGPT realised that yes, STZ was from the C565CO2. This problem, if you were doing this problem with just C programming, and you just use a divide, it's pretty trivial. I mean, you just go and say, you can, well, I mean, one way, I'm just thinking, you could do a percent, so you do a remainder, so you do the modulo 10. So you take your number modulo 10, that's the lowest digit, and then you divide by 10 and do it again, and then you just divide by 10 each time, and then you're picking out the digits, and there you are. But that would be backwards. Yeah, still doing it optimized way is still interesting, but the point is it's not a problem. But the problem I've got here is I've got no way of dividing by 10. Unless I can come up with an algorithm for dividing by 10. So it's interesting. I'm trying to. You wouldn't never do a divide. Try to divide by 10. I can multiply by 10. You want to multiply by 10. You do multiply by 4. Add it to itself. So you multiply by 4. You add, and then you multiply by 2, and that's the same as multiply by 10. You do 2 shifts, an add and a shift. You got your multiply by 10. But you want to do a divide by 10. I'm just going to try JATP. How can I divide by 10 on the 6502? We'll just see what it says. To divide by 10 on the 6502 processor, you can use a process called restoring division. So it's saying initialize the quotient to 0, load y to 10, compare with 0, subtract with carry y. It's doing the 65. It's doing the 65 CO2 as well. There's no subtract carry y. Or maybe there is. I don't know. It'd be good to know. Can I do SBCY? Is SBCY a valid 6502 instruction? Let's check the 65. Because I'm going mostly from memory here. It's like I don't think there is an SBCY. SBCY 6502. This is like ChatGPT versus Google. Let's try the, let's take a get. Now, I think it's nonsense again. 65CO2 instruction set. Have a look at for SBC. So if you could do an SBC, it's subtract Y from the accumulator. It's lying again. See, look, it's not listed. There's no such thing as an SBCY. You liar. And the algorithm that it's putting here then is that it subtracts 10 away from the thing, and if no, borrow increment. It's just doing repeated subtraction. Of course you can do repeated subtraction, but that's a bit slow. It's got to be a better way. But how will we do that? I mean, it'd be nice to have a fast way of doing it. Well, I suppose if I take, let's take an example. I've got 16 and I want to divide it by 10. How you do the subtraction? I don't know. That's the only way I know how to do it. It just feels like that. It's a shame that there's no way I can optimize it by. This is bugging me because there must be a better way, but maybe there isn't. I'm just going to try Google again. I'm going to try with Google fast divide by 10 6502. Multiplying by a constant it gives the techniques here. So what I was saying, you can just use shifts and combinations of shifts and adds. Division. The easiest number to divide by is 2, obviously. Dividing arbitrary numbers. Here's an example that divides the 2-byte number num1 by the 2-byte number num2. Yes. It doesn't talk about constants though. Yeah, that's what I thought. I was reading there's nothing there about division by constants. So how slow would that really be? Is it really a problem? Probably not. Your worst case scenario is a 256 byte value which you divide by 10, and that is, and then you need the remainder. So you take your, my number is probably only going to be in 2 bytes anyway. You subtract 10 away until you're, no, I mean, come on, if I use 2 bytes, I end up, this is not good, because if I've got 2-byte value in there, then I end up with 65536 divided by 10. I'm having to loop like 6,000 times. Yeah, this is why they put the BCD in, I think. Although I wonder whether it would have been easier for them to put a division in. It's interesting. Maybe, tables. I wanted to consider tables. Tabling. Or if it's possible to do it in a similar way that you do long division. Let me check that. So when you do long division, and I take some kind of number like, well, let's do it in hex. So I've got something like, give an example value, I don't know, 17 in hex. And then I want to divide it by 10. We can then go by digit. Can we go that? Can we go by digits like that? It's possible to do it with a long division algorithm. Actually, let me look at that code. I might just rip off that code. There was an example there of right. Let me check something, because it's possible to do a division algorithm that's based on long division, but I don't want to really work that out if there's one already there. So where was that? Divide in 6502. Actually, one thing that's interesting is there is code available in the ROMs from the operating system. There'll be a divide instruction or divide routine probably somewhere in there. This can be a way of saving memory. Divide in 6502. The example code given for a division is not a lot of code. I'm just copying it. We'll paste it in, take a look. This is from a site. I'll take the URL actually and put it in the code. There we go. I think it's interesting. It could be useful to have that division instruction anyway, because it's such a pain. Let's find a nice place to put it. So the division instruction, let's pop it here. It's actually not very many bytes, and I need to think about memory as well, right? Just solder in a maths coprocessor, absolutely. Why not? It's cheating. So that isn't a lot of that's not a lot really. Let's see how this works. The routine there is, here's an example, divides a 2-byte number by another 2-byte number. And I could simplify this for my case, which is that it's dividing a 2-byte number by a 1-byte number. We load 0 into the accumulator and store it in the remainder, and store it in the remainder plus 1. And then we load x with 16. There are 16 bits in num1. That's right. So it's basically doing a divide by, it's doing long division in base 2. And we do the arithmetic shift left of num1. Shift the high bit of num1 into rem. So by doing an arithmetic shift left, it's multiplying by 2, but shifting the top bit into the carry flag. This then, with roll left, is that's a 2 byte, a 16-bit shift left. So it shifts the whole of the number. It's in effect multiplied it by 2. Then the top bit is in the carry flag and then is rolled into the remainder. So it does exactly shift the high bit of num1 into the remainder. That is what it's doing to the remainder. But because we're doing that, we also have to roll again to do the high byte to the remainder. So then, having done that, it does load that, set the carry flag, and you subtract the number from a trial subtraction, it says. Subtract the number away from the remainder. Transfer that to y. Then it does the high byte and said, did it succeed? So it's seeing if it was able to, like, which number is bigger than the other. It's doing a 2-byte compare. If yes, store A into and y. So it stores the result of the subtraction if it was successful. Record a 1 in the quotient. So increment num1. And that is basically a long division routine in binary. That looks like it will work. This isn't too bad. It's going to loop 16 times in order to do your calculation, and I could probably simplify this to do a divide by 10. But let's see if it, I'm going to just see if this works, and then I think I'm inclined to use it instead of I'm inclined to use it instead of BCD. Good night, Apple time. Thanks for tuning in. Good to see you. If you asked about jazz, I will be doing jazz on stream when I've sorted out my performance environment. I'll be doing music streams as well. It's a different thing. I'll have a different intro. Showbiz, eh? Have a good night. So we'll see if this works. What I want to test this divide routine. Oh, there's like a problem is I need memory locations that are set up for this. So we'll just do rem equals num1 and num2. So rem is going to equal, well, let's start with num1. Num1 is equal $80. Num2 is equal $82. Where's it storing the result? Stores it back into num1. Okay. and the remainder is going to equal $8 remainder is equal $8.4, and so altogether we have a nice set of 6 bytes, and let's put that at the beginning. And let's do a testaroonie of the old thing in here. That would be the draw digit thing I had. I'm going to load a immediate, I don't know, some number. Test number 1 is equal, let's put, that's too big, some number that can be held in two bytes, and this one we're going to divide 63305 by 39, and right, I need to load a immediate T num1 and $FF, store a dollar, what was the name of that again? Store that in num1, load a divided by 256, store a num2. What a palaver, just dividing two numbers. So no, num1 plus 1, it's the high byte, that's it. And then do a similar thing here where it's T num2, store it in num2, T num2, store it in num2. How's that? Num1 plus num1 plus, well, right. And then we do JSR divide. Load a num1, store a $8800, storing it to the screen, load a num1 plus 1, store a $88 01. So I've got that in there, and then I want to do this same thing with the remainder. Which I'll store at 20. $21 jump halt. So that's in binary is the result. I suppose I can get a binary calculator out of calc. Because a binary calculator so I'm going to see if this works. So reading the bits up there, I believe I need to switch this into binary mode. Programmer mode, binary. We can read the bits out as 0, 1, 1, 0, 1, 0, can't read those out. I need to put a rule. I need to put a rule. Load a immediate dollar AA, store a dollar 8840 and 8841, and load a dollar 80 immediate dollar 80, store a dollar 8860 and store it in 61. So that should help me out a little bit to see where the bits are. I can read the bits now properly. So let's try clearing that. We can see that we start with a 0, and then there's a 1, and there's a 0, and there's a 1. Let's try that again. There is a 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 0, 0, 0, 1, 1. And so the answer it's giving is 11,139. 11,139 with a remainder of that's quite a big remainder. You can't have a remainder of more than 39. I already have, so it's already broken. Well, let's see if the divide works first of all. Let's switch it back to decimal mode. If I divide 63305 and I divide it by 39, I get it's completely broken. Didn't work at all. Let's go back and check that function again and check the documentation. Here's an example that divides num1 by num2. Divides num1 by num2, which is allegedly what I'm doing. Divide num1. So num1, I load the least significant 8 bits of that and store it in num1, and then I take the same thing and divide it by 256 and store it in num1 plus 1. Then I take the num2 and I take the least significant 8 bits of it and I store it in num2, and then I take num2 divided by 256 and I store it in num2 plus 1. Then I divide and I load num1 and I store it I have it the wrong way round. That's where I've gone wrong. This needs to go, because on the left hand side we want the most significant byte, and so the most significant byte is actually second in the list of whatever Rooney. It's basically the wrong way around. So that explains it. This should be no. That's wrong as well then. I've still got a stupidly large number for the remainder. Well, let's see if I do switch it back to binary, clear carry flag, and read that out. It's 0 0 0 0 0 0 0 0 0 1. It's 6, I think. 0 1 1. Jeez. 1 2 3 4 5 1 1 0, which is 6, and then 0 1 0 1 0 1 1 1, which in decimal is 1006 whatever. If I do memory store, I believe that's correct. So it's 63305 divided by 63305 divided by 39 should be okay. Good. So that division worked. The remainder, though, is a bit of an interesting one, because the remainder that I'm reading here is a huge number, and it should, the remainder surely cannot be bigger than 39. I'm reading that binary value as being 0 0 0 0 1. 0 0 0 0 0 0 0 1 0 0 0. So it's 2000 and 2056, which is not good. So it's buggy on the remainder. You have to be careful. You get code off the internet. I see it cleared the remainder. And see, when it stores, it clears the remainder at the start here, and then it does all of this thingy. Roll rem, roll rem. Store a rem plus 1. Just trying to understand where it looks almost like there's a stray. It's like there's a stray bit. If I was to just take these, if this bit here is, I think, wrong. But if you were to look at this bit, the question is, what's the remainder when you do that division? So to find that out, we'll put it back into decimal. I do a memory, where's memory recall here? Ah, I can just click on that. They've changed the way this works. So what I need to do is take, I was dividing by 39, right? So if I do, give me that number, multiply it by 39, and I get this. And I subtract from that the number that I would subtract from that the number that I was dividing. There we go, which is 63305. 63305. Well, the remainder is 8. That's not good. That's not like anything I see here, right? Oh no, it is 8. I was right. The value that I had... The value is, in nibbles, 0, is a hex value, 0, 1, 2, 3, 4, no, 1. 1, 2, 3, 4. 1, 2, 3, 4. Sorry, yes, it is 8. 0080. It is, I mean 08. 8008. It's a stray bit, so it's almost like there's a carry. It is the correct. It is actually the correct remainder, but with an extra bit set. You think you spotted it? Let's see. Storing rem in 8. Oh, thank you. It's my mistake. So yeah. Thank you. That's the easiest explanation. That was the easiest explanation. There we go. That makes sense. So it's confirmed now as 8, but the remainder is 8. The remainder is, yeah. So that divide routine is working. It requires let's take a look at that divide routine. "16 loops to do the division. And the high and I've just got a 2 byte score. So it's a 65,000 for the scoring, which is fine. But it takes 16 loops. So the problem here is that if I'm converting the number to print it, I've got to do these 16 loops up to 5 times. So it's actually really, really expensive. Really expensive. I'm wondering if there's some kind of trick that can be used here, though. Because the way that the long division works, the way this algorithm here works, is doing division in binary. It says, okay, I've got like I'm dividing by 4. Well, I can't divide the most significant digit by 4. So if I take the 2 most significant digits, then I have 2. And I can't divide 2 by 4. If I take the 3 most significant digits, then I have 5, which I can divide by 4. And so I do. And I write a 1. And then the remainder of that is 4 for 5. It's 1. And so that then continues. Can I put this into the divider, into the remainder of the previous? So no, I can't. When I see how many digits, so it's when I get to 110, I know I'm just saying as an example. So it's basically doing that shifting. I wish I could do that with straight with base 10, but I can't. Well, 10 is 1010. So if I have some kind of number that I want to do with that, 1010, let's try 100. 100 is 64 in hex, so that's 0110 0100. Let's try something. No. Yes. Let's get that into 1. I feel like there is a better way of doing this. Let me try a bit of research. I could work it out, but we're trying to work it out. Maybe if I could try working it out with, then it's going to be very boring on stream. Maybe if I get paint. It just bugs me that it would be that slow. It's got to be a better way. So I could try switching the window capture over to paint, and then let's see how we do this. There we are. No. Right, and then brush. There we go. Thanks for tuning in, KO2. Nice to see you. Should catch up sometime. What I'm going to look at here is basically the algorithm for doing the division. If we give a nice example of like 10 divided by 2, you start off with that, and you can't put 10 into 1, so that's no good. So you try then 2 digits. I can put 10 into 10, and when I do, it goes once, and there's a carry of 0, or borrow 0, whatever. Can I put 10 into 0, 1? No. So we write a 0. Can I put 10 into 0, 1, 0? Yes, I can, once. And there we are, we've divided. we divided it 10 by 2 and we've ended up with 5. That's basically the algorithm, and it's just doing that for 16 bits. What I want to do is divide by 10. What I'm thinking is there's got to be a way to do it with one loop rather than what would be dividing by 10, which takes 16 loops for every digit that I'm trying to get out. So if to divide by 10 is, well, 1010, and the number 100 is 0 1 1 0 0 1 0 0, or 6 4. We try to put these in when we do this division. We are going to get, we can't put this in here. Oh, we can't put this in here, so we write a 0. We can't put this in here, so we write a 0. We can't put 10 in here, that's 3, 0 0 0 1 1, so we write a 0. We can't put 10 in this because this is 6, 10 doesn't go into 6, so we write a 0. We can put 10 into 1100, that's 12. So we write a 1. And then the remainder is 2. So I think what we have to do then is we have to write 1 0 here. We can't put 10 into 2, so we write a 0. We can't put 10 into 101. We can put 10 into 1010. So we write a 1. And we're ending up with 9. So I'm doing the math wrong. What am I doing wrong? Zero, 0, 0, 0, 1. Because that isn't the way the binary works, I'm sort of doing a kind of binary decimal sort of hybrid, which really doesn't work. I think. I'm losing it. No, that's the way it does. The remainder goes in and then it sort of shifts it. It is what I was saying. That was right. So it's just I must be making a mistake because it's 0. I'm really out of practice at doing binary division, long division in binary. 1, because this goes into that once, and the remainder is 2. So the remainder is 10. And this cannot go into 10. This can go into 1010, and it goes in exactly once. And we're done. No, we're not done. And then the final one is 1010 cannot go into 0. And this is 10. So I just made a mistake before. So what we have is we had 10. We have 100 divided by 10 gives you 10. So what I'm looking for is a way to get the digits out. So if I say 100 like so, I need to be able to convert this to this. I'm going to do that on the fly. So 10 goes into 0, no time 1, blah, 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 comes down to here. As we keep doing that, is there anything that we can write? This is doing my head in. 10. I mean, if we try this in decimal, it's going to get confusing when I say this is decimal now. It says I can get 10 into 10 once and 10 into 0 times, and we're done. Okay, let me try something else. If I want to put divide by 10, 3, 2, 1. I can't get 10 into 3, but I can get 10 into 32. I can get 10 into 32 3 times. The remainder is then 2. And then I can get 10 into 21. Two times. And then there's the remainder 1. So when you do this, eventually you pick out the top digit, which is like a 4. I'm missing something. I think I might be trying to do something that's impossible. To convert binary number to decimal without division. Binary to decimal conversion in limited precision. There's a whole article here. Oh, very good. Somebody, it had to be somebody had done some research on this, so this is going to be interesting. It's an interesting problem. It's one of those ones that it's like, it's deceptive. Like I say, there has to be a reason why they would have added the whole BCD mode to the 6502. They wouldn't go through all of that unless there was a good reason, right? And see if I can switch this on to dark reader. That's better. Right. So programmers on binary computers have always faced computational problems when dealing with the textual input-output because of our convention that printed numeric data should be represented in base 10. These problems have never been insurmountable, but they are particularly annoying when writing programs for machines with limited capacity in their arithmetic units. Suppose, for example, you have an unsigned binary number that you wish to print out in decimal form. The following C code will do this. Unsigned int rem equal n%10, unsigned int quotient equals n divided by 10. If quotient is less than 0, put decimal quotient, put char rem plus problem is, this C code assumes that the computer's arithmetic unit is sufficiently large to handle the entire number n. And assumes that the arithmetic unit can conveniently do integer division, yielding both a quotient and a remainder. These assumptions are not always reasonable, both because many commercially successful computers do not include division hardware. This is 1999 that this was written, just for context. And even when such hardware is available, it is of little direct use when dividing numbers larger than the ALU can handle. This is still of importance if you're doing arbitrary precision arithmetic. That is, you want to go beyond the limits of 64-bit formats. So it's still actually relevant, even on bigger machines and newer machines. The focus of this tutorial is on writing fast code to convert unsigned 16-bit binary numbers to decimal on a machine with a 8-bit ALU and no divide instruction, which is exactly the situation I have. This situation is common in all small microcontrollers, and the techniques generalize in useful ways. For example, to the problem of doing 64-bit binary to decimal conversion using a 32-bit ALU. The final section of this tutorial examines how these methods, that's me pronunciation, how these methods can be extended to larger numbers. For example, converting 64-bit binary to decimal on a machine with a 32-bit ALU. On machines with no divide instruction where speed is no issue, it may be simply better to simply use repeated subtraction instead of the fast but algebraically complex code given in the body of this tutorial. Consider the following 16-bit conversion code as an example. Yeah, that's all pretty. Yeah. Variants on the clever algorithm given above have been very popular on clever. Let me look at it then a bit more carefully. What's clever about it? Put decimal, A, B, C, D. Put your... That does seem a bit clever. These variants have been popular on 8-bit processors and microcontrollers, despite the fact that conversions can require over 30 iterations of the for loops in this code. As given here, this code does not work for extreme negative value, minus 32,768. Fixing this bug without introducing a special case is an interesting exercise. Ho ho. The basic idea, to do the conversion faster, what we'll do is look at our binary number as a base 16 number and then do the conversion in terms of the base 16 digits. Consider a 16-bit number n. This can be broken into 4 fields of 4 bits each. The base 16 digits, call them n3, n2, n1 and n0. Okay, so it's 4 nibbles. The value of the number can be expressed in terms of these 4 fields as follows. 4096 n3, yeah, okay. So base 16 arithmetic. In the same way, if the value n expressed in decimal is D2, D4, D3, D2, D1, D0, where each of D3, D2, and D0 are decimal digits, then the value of n can be expressed as 10,000 D4 plus 1,000 D3 plus 100 D2 plus 10 D1 plus 1 D0. Our problem then is to compute the DI from the NI without dealing directly with the larger number n. To do this, we first note that the factors used in combining the values of ni can themselves be expressed as sums of multiple powers of 10. Therefore, we can rewrite the original expression as n3 4 times 1000 plus 0 times 100 plus 9 times 10 plus 6 times 1 plus n2 and so on. If we distribute ni over the expressions for each factor, then factor out the multiples of 100, we get the following. 1000 for n3 plus 100. Okay, it's losing me. We can use this to arrive at first approximations of AI for D3 to D0. I'm just going to skim a bit and see if I can... The values of A are not proper decimal digits because they're not properly bounded in the range of 0 to 9. Instead, given that each of NI is bounded the range of 0 to 16, This is actually quite promising because A3 through A1 are less than 256 and may therefore be computed using an 8-bit ALU. Even A0 may be computed in 8 bits if we use the carry out of the ALU to hold the high bit. Furthermore, yeah, because in effect it's a 9-bit if you consider the carry flag. Furthermore, if our interest is 2's complement arithmetic where the high bit is the sign bit, the first step in the output process is print a minus sign and then negate, so the constant becomes... I'm completely lost at the logic of this. No, that we said is... Given that we've computed the AI, we push the correct ranges, series of 8-bit divisions and 9-bit divisions as follows. I think I have to see the reduction to the code. The first hack at reducing the above idea to code might be to include... All right, just give me the code. Living within 8 bits. The code given above for unsigned printing. The fact that A0 could be as large as 285 forced us to declare the variable D0 as a 16-bit integer instead of 8 bits. We can avoid this by observing that the final addition to the sum used to compute A0 is the only one that we will have to push the sum over 255. Therefore, we only need to check the carry bit once to detect overflow. Having detected the overflow, we can account for it in the computation as follows. I've got a rough idea of what it's doing, but I don't have a full idea. But I'm seeing sufficient text here to begin to trust this person. He's saying so much, he must be right. He's saying a lot of... Yeah. If I don't understand it, it's got to be clever, right? It's a very dubious assumption. Right, in the above code, after having noted an overflow in the computation of A0, we retain the least significant bits of the sum in D0 and approximately correct the quotient by adding 250. If flat-out speed is not of the essence, the easiest way to do the required division is to use the trivial repeated subtraction algorithm. The largest dividend we must consider is only 255, so it will take no more than 28 iterations for this division. This can be optimized in several ways. The above C code is wrong because R is declared to be unsigned, leading to the fact the comparison. Note that in assembly language, this code can be fixed by terminating the loop when the condition codes indicate a borrow after the R10 subtraction. It's interesting to note that you write code that in assembly language where you can just check the carry flag. This is very handy. It's basically what it's saying here. But can you check the carry flag in C? No, you can't. Why not? Very interesting question. Why not? You don't have roll instructions either. Quite sad, really, because there's no really good reason why there wouldn't be, except that they were trying to pretend that in the end, they're trying to pretend that the microprocessor doesn't exist. But anyway, the processor doesn't exist. In another section of the tutorial covers the problem of doing multiplication division using only shift and add instructions. We use the results presented there, taking specific advantage of the limited ranges of values occupied by our dividends to completely eliminate iteration from our code. Wow. Without loops. There are two ways to get an exact quotient remainder from I divided by 10 using reciprocal multiplication in 8 bits. Either we multiply by 0.000 to get an approximate quotient and then compute the remainder and correct the quotient, or we multiply by blah 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 and get an exact quotient from which we compute the remainder. The former method, yielding an approximation, can be reduced to the following C code. Oh, this is clever stuff. Oh. Oh. Really? In the first... This is what I was trying to grasp, but it's beyond me. I was trying to grasp this. I knew there was something that could be done with. This is this yields an approximation. Is this an approximation of a divide by 10, which is just doing shifts? In the first two, right shift and add statements used above, we have assumed that the carry out of the high bit of the add operation is shifted into the high bit of the second of the two right shift operations used in each statement. This can be done efficiently in many machine instruction sets, but even good optimizing compilers may insist on using a 16-bit accumulator for intermediate results of arithmetic operations. Yeah, saying that human can do better than an optimizing compiler. The second approach is a more elaborate multiplier to give the exact quotient. So this is a precise division. Well, even this, if I've got a fast divide by 10, I don't care. At that point, a fast divide by 10 gives me everything I need. And that's the whole point here. Look at this. We take the value that we're dividing by 10, you shift it left, right, you shift it right to, so this is divide by 4 plus I. Oh, yes, I should have thought of that. What happens if you divide by 4 and add the number? If you divide by 4 and add the number, so if I take I shifted 2 bits to the right, I'm taking I and dividing it by 4, and then I add I. So let's say 10. If I do that with the value 10, what do I get? I do 10 divided by 4, which gives me 2. And then I add 10, which gives me 12. But I divide by 2 because there's also this divide by 2 here. So I get 6. But it's like saying here, this is actually the equivalent of multiplying by 0.101. Is that right? I'm just going to check that with a calculator. This is very interesting stuff. I wish I had known, I mean, this is important because I wish I'd known about how to do fast divisions when I was doing assembly programming on 6502. It wasn't relevant when we moved, got to the Amiga and the ST, because they had hardware division. But even so, they were slow. I mean, I'm still using bit shifting as much as I could to avoid those expensive instructions. So let's just try this out. I take 10 and then I divide it by 4. Hang on. Ah, because it's doing it in decimal. Okay, I was wondering why it's a decimal calculator, not floating point. Hey ho. So we do that, then we add 10 to it, and then we divide this by 2. You end up with 6. Now it's saying why does it say times 1.01, 0.101? Because it looks like the approximate quotient, compute the remainder. I don't understand how that in fact works. Oh, right, because it's actually calculating these are Q applied to Q in sequence. Compute the remainder as R minus R equal I minus 10 times Q. I can get a feel. I've got a feel for how that works, but I can't say I've grasped it. The particular choice of one or other of these schemes can only be made after compiling them or hand translation to machine code, depending on the specific features offered by the target architecture. Either of the above may be the fastest or most compact, and careful use of small optimizations may tilt the balance one way or the other. Depending on the space-time trade-offs of the application, the above code may be expanded inline as an open macro, or it may be called as a closed function. If inline expansion is appropriate, it should be noted that the computations of C3 and C4 involve dividends no greater than 65. For dividends up to 68, the multiplier 0.00101 gives exact results, suggesting the following version of the print routine. All multiplications in the above code can be reduced to short sequences of shift and add operations. This straightforward code. All right, I'm gonna go with this. This is a brilliant paper. I knew there was and my guts were telling me there was a way, but I mean, this is a huge amount of work, and I'm going to borrow that work from this paper. This is by Douglas W. Jones from 1999, with revisions in 2002, 2010. And I have, this work may be transmitted or stored in electronic form or any computer attached to the internet or the World Wide Web. As long as this notice is included in the copy, individuals may make single copies for own use, all other rights reserved. There is I'll post that in the chat. Very nice. Well, I'm going to try it. I mean, I don't understand how he got to it. Well, a little bit, but I don't. But it doesn't matter. I don't need to visualize the whole thing to use it here. I'll say this is it. This is the C code that I need to then code as so this I need to code in assembly void put decimal, you give it a number, which is in this case a 16-bit number, and put char minus. Hey Scott, how you doing? Good to see you. I'm trying to do the score. So, which is interesting because it sounds like it's trivial, but there's this problem, a classic problem, of how to convert binary numbers into decimal digits. And it's such a hard problem that the 6502 has a binary coded decimal mode, just so that you can do binary coded decimal arithmetic. Because there's no divide or multiply instruction on the 6502. So I was thinking about how to do the score, and one way is to use binary coded decimal, which is fine, I could do that, but I've just thought of a much better way of doing it just as I was speaking to you. So anyway, I'll finish off the thing. The problem is that this means that the score, I'm feeling a bit foolish, but this means that the score is then represented in memory in binary coded decimal. I don't remember how I did it on the original. At some point I will have to disassemble the original, except that the original's not the real original. I was playing it yesterday or the other day, I don't know. I was playing it, the one that was released from the publisher that made me change stuff, and I hate it. I think it's ruined. And then I'm trying, as I'm remembering, I think it may have been not just changing the graphics that the publisher wanted, but other changes. And so the problem is that the actual original version of the game is lost. I probably used binary coded decimal, and I got wrapped up in the question of there must be a way of solving this problem. And there's a paper that I was just looking at here where it gives this routine that will do it for a 16-bit number, and it's really clever, and it just uses shifts. So the problem here, the thing is, I've just realized I don't need to do that. My objection to using binary coded decimal mode was that then the score would be held in binary coded decimal mode, and that's going to be inconvenient. It's like anything I do with that, it needs to be done in binary coded decimal mode. So if I want to check for, you know, extra lives or anything like that, I need to start using binary coded decimal for it. What hit me just when I was talking to you about it is that why don't I just keep 2 copies of the score? I don't need to do any of this. I just keep, literally, it's a classic solution to a problem. So when I have a routine that adds something to the score, I add to the score 2 bytes for the score. If it's a 65,000, which would be the highest score-ish, odd, that makes perfect sense. So we've got 2 bytes to store the score, and that will take like 3 bytes in binary coded decimal. And what I do is I just add the score to the 2 bytes, easy, and then I add the same score to the, oh, I was going so well. I add the same score to the binary coded decimal. Yeah. The problem is that in binary coded decimal mode, everything you do is in binary coded decimal. So then I still need to convert the score that's been added to binary coded decimal from decimal. But that can probably be done pretty easily if the numbers are not very big. So then I've got the copy of the one that I print. But to be honest, even then it's still a bit of a mess, because the binary coded decimal, I've got the upper and every byte in binary coded decimal holds 2 digits. So you've got to then just sort of like take the lower nibble and the higher nibble, and you're still doing the thing just to print a bloody score. However, this is going to be very fast, you see, because you look at it, there isn't even a loop. That's what's amazing about that, is that with magic numbers in there and stuff, but apparently it works to solve the problem without even needing any iteration. So that's going to be very fast. And then what I can do is extract the digits out to print the score from them. It's one of those things, you know. It's possibly how I did it originally. I don't know. May find out one day. I don't know. But it's very interesting problem, and I'm glad I'm looking at it. But this has left me with needing to, you know, code this. And it's sufficiently simple that I think what I can do is just put it into the routine that will just take the score and convert it into the digits. Well, we'll see. Each one is going to be yeah, I think so. I mean, otherwise the thing only takes 5 bytes to hold the 5 characters. So I think what I'll do is make it go from memory to memory. I could probably do it in 0-page memory, frankly. So I think I've decided that. Then I'm going to use some 0-page memory for this. And since, I mean, I'm starting at 8.0 with my 0-page memory use, because the lower 528 bytes are reserved for the operating system. But who cares, because I'm not using the operating system. So let's do this thing. This is going to be print 16, I'm going to call it, because it's a print a 16-bit number. Now, the way that's going to work is we'll take 70 is going to be the LSB of the number I want to print, and $71 is going to be the MSB of the number I want to print. And then this is going to be the characters out of the print 16 routine, and we're going to just go ahead and do that. So the first thing that needs to happen is, this is handling negative numbers actually, so I don't care about that. I need to have D0, D1, D2, D3, D4. So you know what, I'm going to set variable names here. P16 in equals $70. Let's do this. And then I can do P16 D0 is equal $72. I need to change this. P16 D1 equals $73. It equals, let's do +1, 2, 3, 4, D16, 1, 2, 3, 4, okay, and D0 and Q. We also need to do P16Q is equal 4 plus 1. So we've got all of that so far. Yeah, those are all 8 bits. P16 in plus 2. Right, okay. Then we start with the first instruction, which is D0 equals N shifted 4 and XOF. So we can do load A with P16D1, arithmetic, logical shift right, logical shift right, logical shift right, logical shift right. That's the shifted by 4. I don't need to do the AND at A, XOF because D1 N is the number that I'm working on. Scratch that. I need to have a workspace for if I shift 4 and I want to take, okay, think about this. That was the in value. I need P16 in, the lower byte of the in value of, that gives me the low byte of the input value, which will be at $70. That low byte I have to AND with, I have to shift 4 bits over and do the AND. That's fine then. If I do logical shift right, logical shift right, logical shift right, logical shift right, I've divided by 16. And because I'm not shifting any of the top byte in, we're done. The next one, I need to do, but I need to store it. Store a P16 D1. And let's put in the commentary the pseudocode here. Okay. Cool. I'm being a compiler. The next step is to do this. Now that requires taking the value, which I need to think of as n as being 2 bytes. I need to shift 8 but shifting 8 when you have the 2 bytes is the same as taking the upper byte, so there's no need to shift. So we do load a P16 in plus 1, and that load A, but the rule here is to take the bottom 4 bits, so we need to do and 15, and store that into P16D2, and that is going to be that instruction I think that's looking good so far. Land 15, store A, and P16D2. Yeah. I don't see anything wrong with that. That's the funny thing is divide. There's no shift because I just read the higher byte. Next one, that's that one done. The next one that we're going to do is I need to take n and divide it by 12, or shift it by 12. So this one is a bit of the same, actually. It's the same as this one, except that I start with the top byte because let's see. We load the high byte and we divide that by, and store it in D3. That's that. Because by taking the high byte, I've divided by, effectively divided by, or I shifted by 8, and then I need to shift another 4 on top of that, and we're done. Except we haven't done D0 yet. Well, that comes next. Next we have D0. So it's this code. I think what I'll do is just make it a little better, I think, if I do it like this. Oh. Okay, this code, we need to times 6. We need to take D3 plus D2 plus D1 plus N. N is the lower. Right, let's start with that first of all. So we're going to take the P16 ins, the lower byte of the value that we are working with, and I need to AND it with 15. And so that's given me that. And what am I going to do with it? I need to store it into a temporary P16T1 equals, I need a temporary value because I'm not going to be able to do this otherwise. We'll take, that's going to equal that plus 1. We do that and we store it in P16 temporary 1. Okay. Now I need to add together D1, D2 and D3. So we're going to load a P16 D1, clear the carry flag, add with carry P16 D2, clear the carry flag, clear the carry flag, add with carry P16D3. So let's take that and add those three things together. Now we need to do a multiply by 6 as well. To multiply by 6, the quickest way of doing that is to multiply by 3 and then multiply by 2. You multiply by 3 by multiplying by 2 and adding. So I need another temporary variable. P16 16T1 plus, right, so we'll do another temporary. So we'll do store a P16T2. So that's storing that in there. Now, having stored this in my temporary, I can then do I need to multiply it, so that's an arithmetic shift left. That's multiplied by 2, clear the carry flag, add the carry to that temporary. I've now multiplied it by 3. And then I need to do an arithmetic shift left again, and I've multiplied it by 6. And then I need to clear the carry flag again, and then add it to my temporary T1 that I set up here. Except I didn't really need that temporary T1, actually, because I could have done that at the end, in which case, right, let's go back to this. I'll take D1, clear carry, add carry D2, clear carry, add carry D3, store it into a temporary. I'll just store it in T1 now. We arithmetic shift left, multiply by 2, add it one time, so multiply by 3, then do an arithmetic shift left again, so that I've multiplied it by 6. I clear with the carry flag, and I don't need to do that, do I? Oh. Okay, I think what I have to do now is store A back into P16T1, so I've stored it back into there, and then I can load the P16 in and the bottom 4 bits, clear the carry flag, add with carry P16T1, and we have, and store it in D0, P16 D0. Let's just check that. We load D1, we add D2, we add D3, we store it in the temp, we multiply it by 2, we add the temp, we multiply by 2. Thus I have now multiplied by 6. We load the low byte of n, we add 15, we clear the carry flag and add it onto that temp, which was the 6 times D3 plus D1 plus D2, store it in D0. Okay, so then that's that one done. Let's do the next one. D0 multiplied by OXCD is annoying. That is annoying. How am I supposed to multiply it by OXCD? I just want to see what it says about that, because that's not trivial. Okay, so I have some annoying multiplies in there. Multiply by CD involves shifts and adds. CD is a total of 5 bits. I've got a few of these to do, haven't I? Hey, Mike. Good to see you. What's going on is that I made the font for the score, and then you remember we were talking about like using binary coded decimal, and then I got into my head that I really didn't want to use binary coded decimal, which raised the question of how we can convert. There's this a very old problem. It's like how to convert binary into decimal digits. And I found this paper, which is very nice, which presents this that doesn't even involve any iteration and can be coded on processors that don't have division. Because usually it's got magic numbers in there and things. It's like, I need to have a multiply by CD and a multiply by 1A. But they can be done with shifts. 1A is, I think I'm going to do hardwired subroutines to do those. But I mean, it's pretty impressive. But I've always wanted to do a deep dive into how to do that. Well, this routine here, in the end, should reduce down to. I'm coding it at the moment. Oh, have I? I don't know. I've been programming, but maybe nobody's been able to see it because I had the damn window open. Sorry about that. Here. So if that was the case, I missed the fact that that was not visible. It's a common problem. So what I've got is that routine is now I'm now coding it. I've got I'm doing it a line at a time, and now I have to multiply by CD in hex. So let's see, how would you do that? I've got the value in D0 in this D0 here, and yes. I'm going to make a routine to do that. Actually, I'm going to make a routine to do a multiply by it's not clear to me if, hang on a minute, I need to check that. So Q, D3, D1, D2. D0 times CD. I need to do a 2-byte. I need to do a routine that multiplies to. It's still somewhat expensive, but it needs to do multiply two 8-bit numbers together. You never know when that's going to be useful. So let's just write one. It's not hard to write. Mul 8 multiplying 8 by 8 RTS. Okay, so what we need to do for that is we're going to have I'm thinking about where I can store these to do this thing. It's like we need to have 2 memory locations. So let's do mul 8 by 8 A equals $60. I can move this later. $60. I multiply the B is going to be $61, and then we're going to multiply these together with a loop. So the output is going to be mul it puts it in C. C equal A times B two bytes. So the first thing we should do is load A, immediate 0, store A, and store A plus 1. So load A, immediate 0, store A in mul 8C8. So the output has been cleared to 0. Then we want to load Y with 8. We're going to if only it was so simple. That's not going to quite work. I need 2 bytes for the B as well, so that should actually be 2. This should be 4. No, like that. So the end result needs to be cleared, but I also need to clear the height byte of B, which I've done there. Right, now I'm ready to go. So the routine, I need a loop for this, which starts here. So that's mul, L1, I don't know, whatever. Right. So the first thing we need to do is to check the least significant bit, and the best way of doing that is just to rotate, is to shift, logical shift right the number that we are multiplying B by, or it's A, the logical shift right of A. This is going to happen 8 times. Each time the carry flag is going to be set to that particular bit. So the first time we execute this function, I've got the least significant bit of mul 8 by 8A, which is in the carry flag, which I can then use to a conditional branch, depending on whether it's set or clear. If the carry flag is clear, branch carry clear, we're going to jump over why does it do that? Come on. Thank you. Right. So mul, it's label 2. Right. So what we then do is we need to add B to C. So that begins with the clear the carry flag, load a B, store a mul 8 at C. Oh, not store A. Add with carry, store a mul 8 C, load a B plus 1, add with carry doing chaining it two together to get 16-bit add. C plus 1, store A. Oh, damn. Store A. There, right. So that's a 2. Load a mul. Okay, that's a 2. So I've added B to C, and everything's fine. And we may have jumped around. Oh, I already did that. What am I doing? We may have jumped around it. If we did, regardless of whether or not we jumped around it, we're now ready to go to the next loop. But before we do, we need to shift, because it's basically doing a long multiplication in binary. So we check the first bit, and then we're going to check the second bit. But before we do, we have to shift up B that we're adding to C. So in order to do that, I need to do arithmetic, we'll multiply by 2, arithmetic shift left of B, and then roll left B plus 1. And then we can decrement the Y register, and we do branch if not equal, there, let's see. And then when we finish the loop, we're done. That should be a multiply. That should be a good multiply instruction. Just going to run through it. So I need to store the first value that I'm going to multiply together, 8-bit value. It's 60. Store the second one in 61. The output will be stored as 2 bytes at 63. We load A immediate 0. We store in the output that we're going to add to, but we also have to clear the top byte of that multiply B. We need to be able to shift that into that. We load Y8, logical shift right of A. Let's divide by 2 into the carry flag. And if the carry flag is clear, we skip the addition. Otherwise, we add. Then we multiply B by 2, and we complete the loop. It looks good. Hey, Greg, how you doing? Double dabble, combination of shift and add 6. If you've got a way of doing it, that'd be very interesting. If you have another way, I'm doing fine. I'm going to have to. It's getting late actually. I 10 to 2 here, so unfortunately I'll probably be stopping the stream in about 10 minutes. But I'm trying to do the score, which you know, on a 8-bit 6502 with no multiply divide is actually quite difficult. 11 a.m. there. Where are you in Australia? Which part of the old land? Let's assume that works. Then this code here, I need to take, I need to set Q to D0 multiplied by OCD. Load a, no, yeah, no, load a, this, which are, okay, wow, it's already there, but I'm going to leave it for a minute. Store a, oh, in Sydney, and let me just sort of put these down here. So we have our multiply thing. Right, and we'll come back to this. Right, so what I need to do is take that and I store this in mul 8 by AA, and then I load the accumulator with -oxcd with $CD. That's the, and I store that in mul 8 by B, and then I do a JSR mul 8 by 8. And once I've done that, I have in C the result of this as a 2-byte value. Oh, there's an optimization opportunity there because I've calculated stuff I'm going to be throwing away, but we'll can worry about the optimization if it's important later. The point is that that end result that I've done, I now need to shift 11 bits to the right. Well, I can get 8 by taking the most significant part of mul 8 by 8 C, so 8 by 8 C plus 1, and then I need to do logical shift right 3 times, and so that gives me the divide by, 2 to the power of 11, and that's what I store in P16Q, and then hopefully that instruction is correct. Doesn't let you send. Okay, I'll just open up the chat. Ooh. Oh dear. You ever get a yawn? You do a yawn and you get jaw cramp. Right. I should have a message. Yeah, there it is. Oh, you've got a 6502. Oh, that looks like it might be an even better one. Oh, okay. Maybe I should try this one then instead. Let's see if things compile. Oh. It doesn't like that. Oh, because there was the one from the actual sample C code. Okay. That's fine. Yeah, thanks for that, Mike. It looks like a better routine. That one I was doing was very interesting, but it looks like it was getting involved. I'm going to just try the one that's provided here because this example is what is needed. So okay, well let's try this in say $70. What's block beat? I don't know what that means. All right. Divide instruction HTT in $70 HTT out equal $72. Let's try it like that. There we go to HDD in, right, this function which is called hexadecimal. We have a table, hexadecimal, blah, 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 short routine. Works by some magic. HTD store Z. No, you're welcome. Thanks for watching. So HTTP said blah 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 blah. So this is the code that Mike found. I'm going to give it a go. It looks very nice. It's very compact. By taking x in steps of 3, we don't have to multiply by 3. That's interesting. Let's see, are we compiling? Ooh, loads of errors. Let's start off with line 1157. This syntax is, this assembler uses a different syntax. We're wanting a table here, which that's let's see if this works better. We're going 1157. Yeah, I look at that. I didn't understand that either, but looking at the code, it's just doing a pretty standard add one. Oh, hang on, HTD out is +2. But that's because stored in 3 bytes. Is the output of this going to be... All right, we'll see. One 116. Sorry, what was it? 1157. 1157. What does this H mean? What does the H mean? Ah. What I don't understand this particular. I don't know what these H's mean. Is that hex? Are they meant to be hex? They don't look like hex to me. It's hex, okay. It's just they didn't look like hex, but we'll believe. I'll believe that then. So it comes. I need to just change this to this, and I need a better way of doing that. I'm not going to sit there and do that manually. God, this is a computer automation for the nation. Let's do query replace in region. Anything that is H, replace with nothing. And then all of these need to be double. What's the regex? I can't remember the command for. Right, it's query replace regexp. Right, well, what we do is we look for a number 0 to 9 plus, and we replace that with $\1. Nope, failure. Query replace regex 0 to 9 plus should be replaced with $$1. Nope. Try again. 0 to 9 plus needs to be replaced by, I probably don't need a $$1, \1. Oh, you bastard. It's really annoying, isn't it? It's like it's been a while since I've tried to do this in in Emacs, so it's like, right, 0 to 9 plus $$1. Invalid use of backslash in replacement text. $0 to 9 plus, replace it with $$1. I tried this before. Why didn't that not? Oh, because it's not \$1. That was just me screwing up. Ah, dear me. No back. I've got no sub expressions. That's why it's not going to work with no sub expressions. It's like, yeah. Try again. 0 to 9 plus, replace with $$ and. Rolls eyes. I can do I could have done \$1 if I had bracketed the expression to actually capture the thing. Right. What do we have now? It doesn't like something. On line 115, 1157, 1157. What don't you like? Garbage at end of statement. Unexpected. What? Garbage at end of statement. Unexpected. Oh, that's annoying. Really? Oh, that's me being a fool. It's not FI. That's for zeroed memory. It's pling 8. Let's try again. Ah, well, that's better. Line 1169. 1169. Okay, anywhere we see an H in this code, we need to change it around. What's the next one? 1172. Garbage data at the end of the statement. Yeah, because I can't have $1. I buy that for $1. Okay. Right, that's assembled. Hey Scott. It's assembled. I don't know if it's going to work. I mean, you could try and see, right? I'm quaking in my boots. I really should go because it's late, but can't go at this point. I mean, that'd be leaving everything on a cliffhanger, like, you know, it'd be like, but did it work? So, you know, I'm going to give it a quick go. This was a test of my divide routine. Pling if 0. Let's try a test of that. I'm going to do hash. It's late. LDA 1, 2, 3, 4, 5 and $FF, and we're going to store that into the address that I'm going to split the thing. Where was that? There were these things, HTTD whatever, in store a HTD in. Yeah, that was correct. And then this otherwise is divided by 256, which I'll store in HT plus 1. And then we do JSR HTD, and then we need to load the 3 bytes that we get back. Load a HTD out. Store a, actually I copied that, $8800 HTD out plus 1 plus 1 plus 2 plus 2. Jump halt. Go. Yeah, I need some guides there. Load a immediate $AA, store a $8820 plus 1 plus 2. So I can read the bits, and we need a byte guide as well. Load a immediate $80, store a $8840 plus 1 plus 2, go. There's that letter C has just appeared over the, go away. Right, so what I did was I put in the values of 1, 2, 3, 4, 5. So this routine that we just put in, going to see what we get back. Garbage. Am I missing something? Look, I got back for the four. 4, 5. It's not garbage. It's 4, 5. And I put in 1, 2, 3, 4, 5. Might not be garbage. The next one is 4 again. No. No, it's not. It's not 4. So I'm not showing the nibbles. I'm only showing the bites. That makes it slightly harder to read, but read the binary. But that's definitely 4, 5, and then the next one is 2, and then 3. Oh, it looks like it's working. 0, 1. Fracking worked. So reading that, no, it's fine. I thought it was garbage, but it is not garbage. It is actually, it has worked. What we have is I put in 1, 2, 3, 4, 5 into the input. I call the function, and then I end up with nibbles 4, 5, 2, 3, 0, 1. Looks like they're kind of reversed. So it would be fine if I reverse the order of the bits. Then I would actually have 0, 1, 2, 3, 4, 5. It's just, yeah, it's backwards. Reading the matrix. It's because it's converted it into binary coded decimal. It's actually easy. It's you're reading groups of 4, so you only have to memorize the bit patterns of 16 bit patterns of 4. You can't help but pick that up. Yeah, that's right. It was. So that's really cool. At some point, I'll try to work out how that works. But yeah, that's worked. If anybody wondering how that, I can make it a little bit easier, because you might be going, how does it work? What does it mean? Does it work? If I put 8, 8 in there, it's a bit better. You can see that maybe if I leave a gap, it'll be easier to see as well. So let's try this. I put a gap in there too. So this becomes 4, 4, 4, and 8. So what I'm looking at with this bit is this bit pattern here. That's a bit easier to see. So you can see that between these yeah, thank you. What, the sun is about to explode. What's going on with that? And is that official? The sun is about to explode. That will be the end of all our problems then. Sun activity. Oh, that happened before. It's like... So, let me run that again. I could just go through. Oh, the dark patch. So when you look at that, you can see that the bottom row there is actually 1 pixel every 1 pixel in every 4 bits. So you can think of it, a byte is divided into 2 nibbles, so you can think of it as being, yeah, the start of each nibble is being indicated by the bottom row. The row above is simply bits on and off. So this way it makes it easier to read the bit patterns out. When you go up again, you can see that the first nibble is 0100, which is a 4. The next one is 0101, which is 5. The one after that is 0010, which is 2. The next one is 0011, which is 3. The next one is 0000, which is 0. And finally we end up with 0001. So the routine is, I mean, it's easy to change that routine to output them in a different order. I mean, it's not a problem at all, because I think that routine, HTC, what is the routine? HTC TD, HTD, where are you? Okay, I think I can change the order, but I have to sort of rewrite them in here. It doesn't matter. But the bits would be read out 0, 1, 2, 3, 4, 5. I mean, this routine is going to end up still with nibbles. So when I want to print the score, I'm going to have to still get the top nibble and bottom nibble out. The bottom nibble's easy. The top nibble I have to do 4 shifts, but I don't think it's really going to be a problem. Anyway, that's all I did all evening, was work on the ruddy score. But thanks to Mike, there's this really nifty routine to convert that he found that is really compact and does a conversion by some magic that at some point I will try to figure out how that works. But there we are. You put in 2 bytes and you get out 5 nibbles. No problem. No problem. You're looking at what goes on under the hood. I mean, even for a lot of software engineers, I know that people will say, well, this is nothing like the processes that we use today. Actually, it's not true. The principle's exactly the same. There's a lot of other fancy stuff to do with optimizations and so on. And modern processors are really clever because they do things like speculative processing and branch prediction, but this is all optimization stuff to make things go faster. But in the end, it's the same. And you actually saw me a little earlier. I was actually converting C code to assembly, which is always fun as well. What does all this? So what does this all mean? What does it mean? It means that in my game now, I have a way, because I drew the digits 0 to 9, I created the sprites for the digits 0 to 9, and I have a very simple routine for displaying them. And because they're aligned to byte boundaries, I don't need to do any nasty rotation. So now I can construct my HUD score, where it's going to be the number of lives, and a high score, classic high score and current score. And if you've played Astro Warrior on the emulated web page, I am pretty convinced that it's a messed about version of the original game. It doesn't feel like something I willingly designed. I did do it. So as I remember, I was annoyed with the publisher because the publisher wanted to change stuff and I couldn't be bothered to argue. So I did whatever the publisher said. And I think that included modifying the game design. I find that the one that's there is not good. It's and it isn't how I remembered the game. So I don't know if I'm going to end up. Certainly not recreating Astro Warrior. I hate it, but even though the mechanics are very similar, but I'm going to have to try and recreate what I believe was the original Letteroids, and there's no way of knowing because the original one is gone forever. So anyway, thanks for watching. We'll continue again soon, and I really appreciate the conversation, the chat, and the help. And Mike has joined in. He's got access to the repository. If anybody else wants access to the repository, please, please, yeah, you can actually message me on Gmail chat or whatever they call it now, and you know my name, my code name, whatever, all over the place. I use is DN1011. So that at Gmail you can send me a message there if you're interested in getting access to the repo. Maybe we can do collaboratively. Anyway, thanks a lot, Scott, Mike, Greg. Take care, everyone. It's 2:30 in the morning here, so I think I'm going to have to go to bed. All right. Take care, everyone. Bye. Oh, where's that? Oh, there it is.